Hari Ya तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माशुतप्रभृतिभिः देवैः सदा पूजिता सा मा पातु सरस्वती भगवती विशेषजाड्याः.
Thank you, sir. Now I request our Honorable Director, Dr. Vivek Singh Kushwaha, to address the gathering. Vivek, sir, please.
Thank you so much, Neha ma'am. I'm really thankful to AICTE, who has sponsored the short-term training program. So this is in the third in a row. We have already conducted first and second STTP on financial analytics. So up till now, close to 150 participants attended these STTPs. So I'm sure about it, the benefit of this to be utilized in the benefit of all the students or the budding managers whom we are training. And as these STTPs is concerned, throughout the country, we get participants. So I'm really thankful to all the participants also and the resource persons. So today in the morning, the first resource person, we have with us the Saurabh Agrawal sir, Professor, HBTU Kanpur. And apart from Saurabh sir, we have other resource person in these 6 days STTP, Dr. CP Gupta sir, Professor, Department of Finance and Business Economics, South Campus, University of Delhi. Dr. Sachin Mittal from IPS Academy, IBMR. Dr. Vinay Goyal from SP Jain Institute of Management and Research, Mumbai. Dr. Prabhat Pankaj sir, Director, Jaipuriya Institute of Management, Jaipur. Dr. Shripad Kulkarni from IMT, Nagpur. And Ranvesh Chatterjee from Ocean Financial Services, Bangalore. So these are the resource persons that we have. And as the topic is the financial analytics, I'm sure about it, this is beneficial to all of us as the current trend in finance, when we talk about the stock market or when we talk about the role of information technology in financial sector. So especially machine learning and automated decisions related to finance, then financial modeling, the way we use or the way we deliver in our classrooms, the syllabus that usually we cover. But apart from that, there is a gap that industry is using, the skill set that industry expects. So there's a balance of resource persons from industry as well as from academics. And the content that we try to cover in this STTP is, I'm sure about it, really beneficial. And because of COVID 2019, all these 3 STTPs we conducted in an online mode. Usually we conduct in personal contact mode, but because of this COVID, so I'm sure about it, the content that we are going to cover and the knowledge that resource person is going to share among the participants is in benefit to all of us. So thank you so much, Neha ma'am. Please go ahead with the program.
Yes, sir. Thank you, sir. Thank you for giving the brief of our complete 5-6 days STTP. So, dear participants, today we have a splendid presence of our great educator and instructor, Dr. Saurabh Agrawal. But before introducing our resource person, I once again welcome all the distinguished participants who have enrolled themselves from various regions of the country to be a part of this AICTE-sponsored online short-term training program. We have The resource person as Dr. Saurabh Agarwal, sir. Dr. Saurabh Agarwal, sir, is a graduate and postgraduate engineer from IIT Kanpur and IIT Delhi. He is associated with departments of Civil Engineering, HBTU Kanpur. He's a consultant to IBM and UNESCO for business analytics. He has interest in data mining, data analytics, business analytics, structural equation modeling, multivariate analysis, and works on various platforms like R, SPSS, MOS, Clementine, IBM, Watson Analytics. He has conducted international workshops and training for Saudi Aramco, biggest oil refinery in the world, Gaitanan Bank, Bangkok, KBM Kuwait, Ministry of Road Transport, Abu Dhabi, and prominent domestic training at IMA, New Delhi, Symbiosis University, Pune, KGSIUM Mumbai, VGSOM IIT Kharagpur, Ernst and Young, and Trivandrum. So, heartfelt, we welcome you, sir. Saurabh, sir.
Thank you.
For being with us. Please, sir.
Okay. Let us begin with this session, right? And as per the schedule rolled out to the participants, this session is basically trying to make you conversant with on a tool which we are very popular in the industry right now, right? So my emphasis will be more on how things are delivered or how people are actually using this tool in the industry. So that there is a connect between your research and what is the requirement of the industry. So I start my presentation and I'll stop my video so that there's a better connect. And I'll take you through this session, give you some understanding on how do we use these tools, what is actually research, and something related to the different models which we build in financial analytics. So that will be the focus as far as the delivery is concerned. Now, let me first start with the different kinds of analysis which we do, right? My screen is visible now?
Yes, sir.
Okay. So let us begin with the different kinds, because all of you, mostly the participants come, I think we come from the academic background. So to begin with, I'll first introduce to you what are the different kinds of analytics which we do, right? So that you understand what kind of analytics you could also do as a part of your research. And then what are the kind of tools people are using in academics and in industry to implement these analysis. And then right now in our sessions, the focus will be on one of the tools which we call it as R. And I'll maybe like yesterday I was delivering on a similar tool of Python. So I'll also give you some connect between these two tools. I'll make this session very interactive, right? Anything you would like to ask as a part of your research, any question, right? Not limited to any particular domain, right? Anything which you would like, I'll keep the session very open. So anything which you would like to ask as a part of your research, you are free to ask, because I'm not pinning down any particular analysis, right? So any analysis, any questions that you have in your mind as far as your analysis is concerned, you please feel free to ask. I'll try my best to answer and clear your doubts. So now when we start doing this, the first question which comes to our mind is actually what is statistical analysis, and then how is it different from a very similar term which we call it as data analysis, because these are two terms which people use interchangeably. But we should know, are we doing a statistical analysis or are we doing a data analysis? And then we'll see the different kinds of analysis and then which tool to use. And then I'll give you some demonstration of working on an application like R. I'll try to do some different kinds of tests which we do in R. So all those people who are not familiar with R, they will also get familiar with it, and they'll find working on it very easy. They'll find working on it very easy. And then as I said, any questions you have, right, as far as your research is concerned, all of you are free to ask and clear your doubts. Statistical analysis is the process of collecting and analyzing samples of data. You collect samples of data and then you try to uncover the patterns and trends and predict what could happen next so that you are able to take better decisions. Because the ultimate aim of doing the analysis is to take some decisions which are correct. So how do you take these decisions? When you uncover the patterns and trends, right, which are there in the data which you have collected. The data which you collect is from a sample. Like we are all having this COVID vaccine which is being given to us, but before giving this vaccine, a lot of trials were conducted on the samples. And then it was assured that this vaccine doesn't have any kind of a side effect, irrespective of the age of the person. So all these analysis have been done, and that too in a very short time. So that it could be implemented as soon as possible, looking into the vast population.
Saurabh sir,
Yeah.
sorry to interrupt. Sir, participants are requesting like to increase the volume as it is somewhere like what low volume aa raha hai, sir.
Okay. Yesterday to ma'am I said. Okay.
And even I request participants to please use your headphones. That will make it clear. I mean, sound will be clear.
So basically, you collect data and you analyze it so that you are able to make more or better scientific decisions. So it's a process of collecting and analyzing samples of data. Because it's difficult to collect the data for the entire population. So you basically collect data from a sample, and then you make sure that whatever results that come out from the sample are applicable to the entire population. So that is what is statistical analysis, right? The next term, which is a little more confusing, is somewhat simple to this, is what we call it as the data analysis. Now, this is the process of inspecting and cleaning all the available data. In statistical analysis, most of the data is already cleaned. But in data analysis, you have large chunk of data, and then the first thing you do is to clean all the available data and then transform it into some useful information that can be understood by non-technical individuals. Because the decision makers are generally those individuals who do not have too much of statistical understanding. So you deliver your results in such a way that these results could be implemented and the crucial decisions can be taken. So basically, statistical analysis is basically for those people who have a flair of statistics. Data analysis is for those people who actually don't understand statistics, and you convert your results into a language which these people can understand and take some kind of a decision. So you could do either statistical analysis or data analysis. I just wanted to pinpoint what's that minute difference between, or a hairline difference between, when you write that you are doing a statistical analysis and when you write that you are doing a data analysis. Now, once you start doing the analysis, the two first analysis which we generally do is what we call it as the descriptive statistics and the inferential statistics. This is the two analysis which we generally do when we start doing either statistical analysis or data analysis. So what are these two things? The first one is what we call, as you can see on my screen, is what we call it as a descriptive analysis. Now, here you try to tell some kind of a descriptive of the data which you have collected, right? Now, what can be the descriptive statistically? Like the mean of your data, the median of your data, the standard deviation of your data, right? The variance of your data, covariance of your data, correlation of your data. That is all what comes under descriptive statistics. That tells the person who is going through your research what is the kind of data which you have collected. So you need to tell the statistical value with what actually it means. What actually it means. What actually you mean by a mean value. What actually you mean by a median value. What actually you mean by the quartiles Q1, Q2, and Q3. But all of them are reported under one umbrella, which is what is known as the descriptive analysis. I have seen most of the research papers where most of the people do not do any descriptive analysis. So that descriptive analysis tells actually what is the kind of data which you have collected. आपने किस type का data collect करा है, that is what is indicated using descriptive analysis. You can do it in numbers, or you can describe your data in a visual manner using number of graphs like bar graphs, box plots, right? and clustered bar, scatter plot, all that you can do when you describe your data in a visual manner. So I suppose the first part is clear. The first part which you do as a part of your research paper is your descriptive analysis, right? So let me just ask for all the participants who are attending, right? How do they differentiate between a mean and a median value? What is your understanding between the interpretation of a mean and a median value? Suppose I've tried to calculate the mean of a reading score and a median of a reading score. So what do you think is the difference between the two values? Anybody? So that you are all involved in the discussion. So that all of you are all involved in the discussion. So what do you think is the statistical difference between a mean value and a median value? Can somebody? Can
Sir,
somebody try?
mean value is the average of all the observations which we have done.
Yeah,
And in case of median value, it is the medialmost value of the observation.
it is the middlemost value. It is the middlemost value, or generally you say that's the positional average. That is the positional average, right? So once you say it is the positional average, then people can understand, right, that 50% of the cases have a value above it, and 50% of the cases have a value below. अब लोग please थोड़ा सा microphone off कर लो, right, so that other people don't get disturbed. Right? So this is the difference between mean and the median. Median is also known as, can somebody? Median is also known as, what is the other term for the median when you write descriptive statistics? What is the other term which we use for the median? What is it actually, or what is the other term which is known as a median? So there, this is median is also known as what? Median is also known as quartile 2. It is also known as quartile 2. So in descriptive statistics, two things are more. One is that you should always tell the quartile values, and there are 3 quartiles: Q1, Q2, and Q3. Right? Why is the quartile important? Can somebody suggest why are the quartile values important as far as the analysis is concerned? What do you find out using the quartile values in your data? What do you think you find out using the quartile values in your data? See, all this is important when you start doing the financial analytics. All this is very important when you start doing the financial analytics, right? So under descriptive statistics, right, this is what I'll be demonstrating also once we work on R, right? So I'll write a few things. I hope my screen is visible, right? So there is something known as the mean value, right? See, you don't have to just report the mean value. You need to also find out what actually it is trying to tell in your data. And the other is your median value, right? Now, what do you think is the importance of the mean value? Where is the mean value important as far as the statistical analysis is concerned? Can somebody try? Where do you think is the importance of the mean value? Just getting the mean value is one thing, but where do you actually use the mean value? Where do you actually use the mean value? What is that you can infer using a mean value which you get from descriptive statistics? Can somebody try? Because all of you must be involved some kind of a research, right? आप लोग कुछ research जरूर कर रहे होगे, right? Or you must be involved in doing some kind of an analysis, some kind of a research, or you have done some kind of a research, right? What I need to know is, how is the mean and the median value helpful as far as the analysis is concerned? What is it pointing to? Just getting the mean and the median value is one thing, but how is it useful as far as the analysis is concerned?
Sir, we can understood the trend of the data. That
You
is
understand
the trend of
this?
the data.
Yeah,
Because mean and median is the focal point, and around it, whether all the data are that are coming around it or not, that we can understand from the mean and median value.
So you can find out how many data are close to the mean and how many data are close to the median.
Yes. How many data close to the exactly.
Yeah, okay.
It will also help us for understanding the deviation also.
It will also
that when we find out standard deviation, how much it is deviating from the average value.
how much it is deviating from the average value. Now you are reaching to that point, which actually is our focus, right? So how much is it deviating from the median value? That idea you can get from both the mean value and the standard deviation. Standard deviation is the deviation from the mean. Now this is pure mathematics, right? In pure mathematics, we find the mean value and the standard deviation. And you can use any tool to get this mean and standard deviation in a second, right? But our interest is, how do we use it in financial analytics? How is this mean and median value helpful as far as financial analytics is concerned? Because you need to apply, right? It's not just calculating the values. These values are pointing to something as far as the analysis is concerned. So that is what you need to focus on. Where do you think still that answer has not come out, right? Where do you think the mean value will be helpful as far as your data is concerned? Where do you think your mean value will be helpful? Which analysis you do depending upon the mean value and the standard deviation. Suppose I take standard deviation also into account. So you have the mean value and the value of the standard deviation. Now, what will you do with this value? That is what my question is, right? So just seeing the value will not help you anything, right? What do you infer statistically from the mean value and the standard deviation? Standard deviation is giving you some idea how much it is deviating from the mean. But the question is, where do you apply these values? What results do you need to work out from these values? So I'll tell you now, these are some statistical concepts which are very important as far as the financial analysis is involved, right? And then I'll go a little more deep into the different kinds of financial analysis which we generally nowadays focus on, right? This is a burning issue right now, right? Working on financial data for anything, right? Data, generally the data, you have a large data which is generating right now, right? Those days are over when you prepared the primary data, right? Now too much secondary data is available on the net, right? If you don't know where the secondary data is available, I'll tell you the websites where you can look for the secondary data. But I assure you that too much of secondary data is getting generated every minute, right? Somebody is interested on working in a model to predict the stock prices. Somebody is interested to work on a model to predict. Financial analytics works everywhere. Anywhere finance is involved, financial analytics will come into picture. So you have a large number of things which you can do, but then your basics should be clear. Now this mean value and standard deviation is helpful in the concept which we call it as the normal distribution of the data, right? Now, this concept is very important. This is the normal distribution of the data which you have collected, right? So, this mean value and standard deviation gives us some idea about whether the data is normally distributed or not. Why do you think the data should be normally distributed? Why do you think the data should be normally distributed?
So, sir, if it is skewed data, then it may happen that the interpretation may go wrong, because the bell curve which it is showing may not give the proper answer actually for us.
So naturally, right, and then we'll come to, right, why getting a normal distribution is difficult. But the first important concept to understand is, right, that why do you think the normal distribution is important, right? So I'll tell you this example. Suppose we were doing a number of trials for this COVID vaccine, right? And naturally, I told you I was involved for one of the analysis. So we collected some sample of the data, right? Now, suppose you are doing it, I'm doing a clinical trial for the city of Indore. It has a huge population of 20 lakhs, minimum, I think so, right? So you cannot collect the data for the entire population and see the effect of the vaccine, right? So what you do is you collect a sample of the data. Now, whatever results you get from the sample of data should be applicable to the entire population. When can this happen? When do you think this can happen? When can you impose the results of the sample on the population? You are not doing your research for the sample, right? You are doing your research for the entire population of the data, right? So when do you think the results which you get from the sample will be applicable on the entire population? This can only happen when your data is normally distributed. If your data is skewed, your results cannot be applicable. Right? You must have heard in the newspapers that all the clinical trials were not completed and the vaccination started. That was again a hue and cry. All the trials should have been completed before the vaccination had to be given, but everybody was in a hurry. So vaccination started, and the phase 3 of the clinical trial is still going on. That is the actual reality. Why? That was getting delayed. Why? Because we were not able to get a data which was normally distributed. See, research takes time. It's not that it's a blink of an eye, right? So we were trying to work on a data which is normally distributed. So that is where whether the data is normally distributed or not, that depends upon the concept of the mean value and the standard deviation. Right? Now, when do you think your data will be normally distributed? What is that? Not going too much into the test, right? Test we'll do in R, that I'll show you, not a worry, right? But then हर चीज का आपके पास में एक you should have, if you need to succeed na, you should have a thumb rule of everything, right? Then only you can move forward, right? Anybody, when can you think your variable is normally distributed? Anything you can cite on the basis of mean and standard deviation? Anything you can cite on the basis of mean and standard deviation which you get from the descriptive statistics? When do you think the mean and standard deviation can tell me that my data looks to be normally distributed? Anybody? Anybody?
When mean is equal to 0.
When
Mean is 0.
When mean is 0, what happens? Is it, ma'am? When mean is 0, then what happens?
The bell-shaped diagram will be created, which means the data is normal.
Mean is 0 for what? Mean is 0 for not a normal distribution. Mean is 0 for a standard normal distribution. There's a difference between a normal distribution.
Yes, sir.
There's a difference between a normal distribution and a standard normal distribution. Right?
Okay.
Normal distribution mean will never be 0. But when you convert these values to a standard distribution, normal distribution, the mean becomes
standard normal distribution.
the mean becomes equal to 0. But as of now, I'm not converting it into a standard normal distribution. That we'll do when we start doing the forecasting. When we do start doing the forecasting. But now, suppose you have a data for a variable, naturally you have some value of mean and you have some value of standard deviation, right? How can you find out that, sir, am I going in the right direction or not? This is what I was doing. I was collecting data every day, and I was keeping in mind that my ultimate aim should be what? I should get a data which is normally distributed. I should get a data which is normally distributed, because if I don't get a data which is normally distributed, whatever results I get from this analysis will not be applicable to the entire population of Indore. Absolutely not possible. Absolutely not possible. Right? That is why research takes time, and that is why research is tough, because getting a data itself which is normally distributed takes time. Right? So suppose you get the value of the mean and standard deviation. Now I'll tell you a thumb rule, right? This rule has come out from the basics. I'm not telling you anything which is something out of the box, right? But this is coming out from some basics. Now what it says is that you calculate mean and standard deviation and find out what is the value of mean plus standard deviation and mean minus standard deviation. All of us can do it, right? So we can find out mean plus standard deviation, and then I'll show you this also in R. How do we do it in a very simple manner, right? Mean plus standard deviation, and you find out mean minus standard deviation. Simple. Now, let us assume that mean plus standard deviation is 60. Let us assume, right? And mean minus standard deviation is 40. Suppose, right? Now, when do you think this variable will be normally distributed? Anybody? Anybody? I just gave you some hint, right? I got the mean and standard deviation, right? Getting mean and standard deviation is very easy. You just need to write a piece of code in R. You'll get the value of mean and standard deviation. But now, when do you think this variable is normally distributed? If you find out in your data set, suppose your sample size is 200. Sample size is 200. sample size is 200, right? Now, you find out what this thumb rule says is, you find out how many values in the data are between 40 and 60. How many values are between 40 and 60? Now, suppose between 40 and 60, the number of values out of 200 is 100. So the number of values is what? Number of values. I'm just trying to tell you how do we do it actually, right? Automation is very easy. Number of values between, because understanding the concept is very important. So the number of values between 40 and 60, between 40 and 60, if I count it, is suppose is 100. Now what I do is, they ask me to calculate the percentage. So naturally the percentage is what? 100 divided by 200 into 100. So the percentage is 50%. Percentage is 50%. Simple, right? Now, if you find the area under the curve, between mean plus SD and mean minus SD, then it is 68.3%. 68.3%. That is the area of the curve between mean plus SD and mean minus SD. That means if your data is normally distributed, the percentage you got is 50%, is less than 68.3%, and your data is tending to be not normal. Your data is tending to be not normal. So the minimum percentage you should get is between mean plus minus SD is 68.3%. This is the first basic criteria which will tell you whether your data is normally distributed or not. This concept of normal distribution is very, very important, right? So many people have seen, they complete the entire research, but if I ask them, was their variable normally distributed or not, they do not have any answer. I feel sorry that you don't know whether the variable is normal or not, and you have completed your research. How have you done it? I don't know. So you should know at least your variable is normally distributed or not. Why do you think normality is important now? Why do you think normality is important? Why do you think normality is important? जब आप अपने research करोगे, right? Why do you think you should find the normality of the variable? Anybody? इतना discussion के बाद में, can somebody say why do you think that the concept of normality is important? Can somebody reply here?
Yeah, symmetry के लिए मतलब it should be same output जो result आए वो population पे भी equally effective हो. मतलब जो हमने
population पे भी equally effective हो. Otherwise, whatever you are finding from your research has no relevance.
Yes, sir. बोला अब ज़्यादा fluctuating होगा तो फिर वो unreasonable output होगा हमारे लिए.
Unreasonable output का नहीं है. The major issue is जो आप पूरी research कर रहे हो, that research cannot be applied anywhere. You are just doing it for the sake of doing it.
Right.
Sir, in that case,
so if your data is not normally distributed, right? अब पहला तो concept ये है कि आपको पता होना चाहिए कि normality इतनी important है, right? Many people, there are 90% of the people who don't know that normality is important, and they start doing different kinds of analysis. That analysis doesn't have any meaning, right? So the first thing I want to assure everybody, आप लोग क्योंकि ये सेशन अटेंड कर रहे हो, कम से कम आप आज के मेरे सेशन के बाद में you start appreciating that the concept of normality to begin with is very, very important. The reason I'll underline. The reasons are, first, so that the results of your sample can be applicable on the population. First. Second, it will help you to select which analysis to do. Right? आपने बहुत सारी analysis के नाम तो सुने होंगे. ANOVA, t-test, regression, and so many other analysis, right? But the question is, which analysis to do? The very big question is, ये question एक ऐसा question है which even Google cannot answer, right? You don't know whether your variable is normal or not, and you are doing a linear regression. I don't know how do you do it, right? This is the quality of the research actually, right? That is what needs to be improved, and maybe this session can help you improve the quality of your research.
So in that case, we cannot generalize whatever our interpretation is there for entire public, right? So if our sample size is not right, if the normal distribution is not there, and the skewed means bell curve is not there, and there is then skewness in our graph. In that case, whatever the interpretations are there, whatever the results are there, they cannot be generalized, right?
They cannot be generalized and they cannot be applied on the population.
Yes, yes.
And if your results cannot be applied on the population, I'm testing the vaccine. If I cannot apply my results on the population, how can I give the vaccine to the entire population of Indore? That is not safe. That cannot be done actually, right? So you are statistically wrong. That is why this research takes so much of time. Right? You cannot apply a skewed results on the entire population and then take that risk for that complete city. That needs to be, those people who are responsible for it, they understand the advantage of the correct data. So the first situation is that your data should be normally distributed so that the results of the sample is applicable on the population. Now, many a times you get a data which is normally distributed. Many a times you get a data which is not normal, because that is the intrinsic nature of the population. That is the intrinsic nature of the population. So ऐसा नहीं है कि अगर आपका data not normally distributed है, so you have hit a block or you cannot move forward, right? There are many analyses which can be done on a data which is not normally distributed, and then the results can be applied on the population. That is where the selection of the correct analysis comes into picture, right? I'm not trying to say that because many a times the population itself is skewed. If the population itself is skewed, how can the sample be not skewed? And if the sample is not skewed, then naturally it is not normal. If it is not normal, I'll go for an algorithm which is applicable to a not normal distribution. But then the selection of the correct algorithm is very important. So how do you select the correct algorithm? Only once you know whether your data is normally distributed or not. So that is why the concept of normality is very important. I'm not trying to say that if the data is skewed, you have come to the end. No, I'm not trying to say that. That was the story 10 years back when we never had algorithms for a not normal distribution. Now we have many algorithms in financial analytics which is not normal, right? And more true for a data in financial analytics, because getting a data which is normal in financial analytics is very difficult. आप डेटा सपोज स्टॉक प्राइस का ले लो, आप पिछले एक महीने का डेटा ले लो स्टॉक प्राइस का, and you find the normality, you will not get it is normally distributed. That means that doesn't mean you have reached the end and you cannot do anything. You have analysis. I'll tell you what are those algorithms which can be applied on a data which is not normally distributed. लेकिन आपको पता तो होना चाहिए कि आपका वेरिएबल नॉर्मली डिस्ट्रीब्यूटेड है कि नहीं है, जिससे कि आप करेक्ट रास्ता चुन सको. You are coming from your home to the place of work, to your college, right? You should know which is the correct road to take. Then only you will be able to reach your institute in time. So that is the first thing you should report as far as the data, exploratory data analysis is concerned, that whether your variable is normally distributed or not. Now, the thumb rule is this 40 and 60, the data between 40 and 60 should be at least 68.3%. That should be 68.3. जितना आपके data का standard deviation कम होगा, the more are the chances that your data is normally distributed. Because I want most of the data to be concentrated about the mean. I want most of the data to be concentrated about the mean. Now, to find whether the data is normally distributed or not, you have a number of tests also in statistics, right? So how do you test for normality? Test for normality, right? The thumb rule I have told you that this is the thumb rule, but then what are the recommended tests for normality which we generally do? Can somebody give a try? It's not that difficult here, because if you don't know these concepts of normality and what are the associated tests, then you need to go and work on it, right? That is what I can tell you, right?
हम डेटा को ग्राफिकल रिप्रेजेंटेशन से बेल शेप आ रहा है कि नहीं ये चेक करते हैं, स्क्यूनेस चेक करते हैं,
आप
मतलब
ये
उसकी
भी
जो
चेक कर सकते हो. One is to make a bell shaped
ग्राफिक
curve,
बेल
right? Or a
शेप, यस सर,
graphical plot, right?
यस
So,
सर, यस सर,
but graphical plot should always be supported by a statistical test, because sometimes
राइट,
looking at the plot, you are not sure whether it is normally distributed or not. So you should support your graphical plot with some kind of a test, which is the ultimate to tell whether your variable is normal or not. So I
सर
would just
जारकर वेरा टेस्ट इज फॉर नॉर्मलिटी ओनली.
know what is the most popular test. See, you should use a test which is popular, which is
Shapiro-Wilk
a test
test.
which is reliable, right? That is what
जी
is
सर,
known as the Shapiro's-Wilks test.
यस यस, Shapiro's Wilks test, यस सर,
Shapiro's-Wilks test. So
यस सर,
I'll
यस
show
सर.
you this test and its interpretation in R, right? It's a very popular test, right? So we'll see the Shapiro's-Wilks test, right, to test the normality of the variable. The other plot you can do is, that is what is known as a QQ plot, QQ plot, or a
यस सर,
quantile.
क्यों क्यों.
Yeah, this is known as a quantile plot. I'll show you this plot also, right, which will tell us whether the variable is normally distributed or not, right? So quantile plot. I'll show you both of these things in R, right? So the second thing is, these two things you should give as a part of your analysis. One is the quantile plot, which is supplemented with the results of the Shapiro's-Wilks test. These two are good enough to tell whether your data is normally distributed or not. Okay? And the third thing you can do is, you can also make a histogram. That will also tell you vaguely whether your data is symmetrical or it has skewness to the left or skewness to the right. But the most important thing I want all of you to appreciate is the concept of normality. If you don't appreciate this concept, moving ahead in doing analysis will be very difficult. Will be very difficult, because we take lot of decisions based on whether your variable is normally distributed or not. If it is normally distributed, then this is the way out. If it is not normally distributed, then this is the way out. Selecting the right way is very important, because if you don't select the right way, then you will be hitting, or your research will give you results. Naturally, your research will give you results, but the results will not be correct. Like yesterday, again, there was one of the sessions going on in which one of the participants said, "Sir, I got these results from R." So what? Even if you get the results for R, that is not a guarantee that your interpretation is correct. The reason is, you have used a wrong analysis. You have used a wrong analysis. Right? Your selection of linear regression is absolutely wrong. So even if you get a result from linear regression in R, it doesn't have any meaning. So you should not say that because you got a result from one of the tools, you are right. So this is the first concept which I wanted to put across, right? Which is the concept of normality of the variable. See, I'm not trying to say that you should always get a variable which is normal, because getting a variable which is normally distributed is very difficult. It's very difficult. But you should at least know the data which you have collected, is it a normally distributed data or not? The reason being, your selection of the correct algorithm will be based on the normality of the variable. The normality of the variable. So at least I want, after my session, you should appreciate these small concepts, because when you work on a bigger concept, these smaller concepts will have a very big role to play. It will have a very big role to play. And we'll see how, just with the blink of an eye, you can find out whether your variable is normal or not using the Shapiro's-Wilks test and the quantile plot, which is a visual representation of whether your data is normally distributed or not. And this concept is even more popular when you talk of financial analytics. This concept is even more popular, or more that needs to be taken into account as far as the data for financial analytics is concerned. So we'll see how to check for the normality of the variable. But normality is basically based on two things. One is the value of mean and one is the value of standard deviation. And the thumb rule is what? That you should have a small standard deviation. I want most of the data to be concentrated about the mean. Then only I can pass that 68.3%. That is a fixed value that the data between mean plus minus SD should not be less than 68.3% mathematical. 68.3% mathematical. Then the second concept is, suppose you have collected the data and you have examined for the normality. You have examined for the normality. Right? Let me complete this discussion and then I'll show you the same concept on R. How do we implement it? By writing a very small piece of code in R. Right? And why am I using a tool like R? Because many people would like to know, sir, why are you using this particular tool? And can I also use it once I go out from this session? The second concept which is important is, right? Now suppose I have a data, right? One is the value of the normality, which is important, right? The second is the concept of quartiles and median. Quartiles and median value in the data. Now I told you what is median. Median is also known as Q2 or quartile 2. It is also known as Q2 or quartile 2. Median is what? Median. What is the difference between mean and average? Somebody? What is the difference between mean and average? When do you use the word mean and when do you use the word average? When you are writing your research paper, I've seen people writing somewhere something, right? So when do you write the word mean and when do you write the word median, average? Can somebody try? Just try. जो भी आपको answer, जब आप when you debate on an issue, then only you will get some answers, right? If you speak, if you don't participate in the discussion, I don't think you will be able to understand anything, right? So when do you think you should use the word mean and when do you think you should use the word average in your research paper? Mean refers to what?
For sample, we calculate mean.
So whenever you have collected the data for a sample, then mean is of a sample.
Yes,
mean
and for average for population?
Mean is for a sample and average is for a population. Average is for a population. So do remember, right? Average is for a population. Average is represented by X bar and mean is represented by nu, symbol nu, right? That is for the mean. So you should know that if you are working on a sample, then you need to write the mean of the sample. And if you are working for the population, then you say this is the average for the population. Now next is, how do you interpret the value of the median? Because this is also very important. Now median is what? Median is positional average. Median is positional average. Median is what? The positional average. Now suppose I say that my median is 60. What does it mean? Can somebody? What is the interpretation? If I say my median from the calculation is 60, then what does it mean? What does it mean? What do you think does it mean? When I say that the median value is 60, what is your interpretation?
Data circulate around 60. The range should be from, the middle range should be 60 because 60, it shows
the median
position.
Value, the median value is 60, right? What do you interpret it statistically? What is your interpretation statistically? If I say median value is 60, right? What do you interpret? What do you
That
interpret
the
statistic?
center of the data should be nearby 60.
The center of data is 60, right? Can somebody else try? Can somebody else give an explanation when you mean by median value is 60? If suppose my sample size is 100, if my sample size is 100, then what does it mean?
The
What does
most
it
of
mean?
the data,
What do you mean by this?
So 50
That
observations
means
have value.
50
Hello?
observations,
Have value more than 60.
50 observations have value more than 60, more than 60, right? Have value more than 60, and 50 observations have value less than 60. That is what is the positional average. That is where is the positional average, right? Now, similar to median, there are two more things. One is Q1 or quartile 1 or quartile 1 or quartile 1. And there is one more descriptive statistics, Q3. This is quartile 3. This is quartile 3. This is quartile 3. Right. Now, besides normality, what is that other thing which tries to tell me the nature of the data which is collected? That means whether my data is good or bad. See, if your data is not meeting, is not good, right? जैसे आपके घर में drinking water आता है, the quality of the drinking water is not good. So what you do is you put some filter, you put some an RO or something like that, and then you distill the raw water. Similarly, you are trying to see whether the data which you have collected has a good quality or not. If the variable is not normally distributed, then naturally your data may not be meeting the quality standards, right? Similarly, besides normality, do you think there should be something which should be looked into? And that is why we are trying to get the value of the median and the quartiles. Suppose, I'll just make my question a little more easier. Suppose I collect the scores of students. Scores of students, right? And the scores are between 0 to 100. Scores are between 0 to 100. And my sample size is 100. Right. The first thing I'll do is to check the normality. The first thing I do is to check the normality. Right. If it is not normal, what could be the reason? If it is not normal, what could be the reason? जैसे आप पता करते हो, if you have fever, what could be the cause? Because until unless you determine the cause, you cannot remove it. So if you have a variable which is not normal, right, then you investigate why is it not normal, why is it skewed? Then only that skewness can be removed, right? So what could be the reason? What do you think could be the reason of the skewness to begin with? That what is that called in statistics? What is that called in statistics? Because
wrong sample size.
Your sample size is 100.
Okay.
Your sample size is 100.
And
right.
If we change our sample size also, that can be
But
one of
that
the
decision of changing the sample size could only be taken if you know that this is the reason that you increase or decrease the sample size.
Sir, when the data is skewed, what we can do is the normality test can be changed. As if it is normal, we usually use sharp, then as you told quartile also. But we can change the test also. If it is impossible that the data is not, we are not able to.
You use any test for normality, right? If it is normal, the test will tell you it is normal. Changing the test will not make not normal into normal. Changing the test will not make a not normal sample into normal sample. Why will that happen? Why will that happen? If you cannot reach the institute in time, the institute will not shift its position and reach to location B. That will never happen. Right? So why are you getting a skewed distribution? That needs to be found out. Because if you don't find why is you getting a skewed, how will you make it normal now? How will you make it normal? So what I'm trying to put across is what could be the reason for skewness? That is known as what in statistics? That is the second important concept which you need to figure out, right? What is that? Suppose I just give you an example that the marks are out of 0 to 100, right? These are the marks of the 100 students which we have collected, right? Now your data is skewed. It is not normal, right? What could be the reason? What could be the reason? आपका फोकस उस पे होना चाहिए which determines the cause of normality. If you start hitting the bush here and there, nothing will come out, right? So why do you think it is not normal? That skewness is because of what? That skewness is because of one more concept which is known as, I don't, you should all know this, right? So that is because of known as outliers. These are known as outliers, right? Outliers are what? Outliers are what? इसको और क्या कहते हैं?
Exceptional value. Yes, sir.
Outliers are what?
Exceptional value. Sorry.
These are also known as, outliers are also known as, रिसर्च में outliers को क्या कहते हैं? Outliers are
Errors.
no, they are known as extreme values.
Extreme values.
They are known as extreme values. They are not known as errors, right? So suppose you collected the score of 100 students. What you did was, by mistake, you collected only for the weak students in the class and the exceptionally good students in the class. Those values can be an outlier. Those values can be an outlier because either they are very close to 0 or they are very close to 100. Even they are a part of your sample size. तो कल आप आके ये नहीं कहोगे कि सर मैंने तो डेटा 100 का कलेक्ट कर लिया, बट यू आर नॉट कॉशियस इनफ कि किन स्टूडेंट्स का डेटा आपको कलेक्ट करना है. That is what we known as outliers. Now, how
Sir,
do
our
you
blocks plot also shows our outliers, right?
Yes, correct.
Yeah.
So outliers can, very good, very good. Outliers can be found out. Outliers can be found out using box plot. That also I'll show you. Using box plot. Very good. Right. But how do you find an outlier? Box plot is one thing. आपका statistical concept strong होना चाहिए. Right. आपकी knowledge superficial नहीं होनी चाहिए. Right. When do you think you get a value which is an outlier? उसके पीछे जैसे मैंने आपको नॉर्मेलिटी का कॉन्सेप्ट बताया, that 68.3% should be between mean plus minus standard deviation. You use any statistical test, the concept remains the same. The statistical test will make your life simple by telling you whether it is normal or not. But tomorrow, if somebody wants to discuss with you, then you should be technically sound, right? That this is not a normal distribution, sir, because that 68.3% values are not between mean plus minus. You go and purchase a drug or something, some ailment, right? Just don't believe in the name of the drug. You should also find out what is the chemical composition of that drug. What is the chemical composition of that drug, right? That will make you believe whether you are using the right drug or not. Similarly, आपको पता होना चाहिए, if it is not normal, what is the reason? Shapiro's test will tell you normal or not normal. लेकिन आपको ये भी पता होना चाहिए क्योंकि कल आपको हो सकता है आपको उसे नॉर्मल करना पड़े. तो आप क्या करोगे? You will try to bring 68% of the values between mean and plus minus standard deviation. Similarly, you can make a box plot to find out. Somebody said it very right, right? Absolutely right. You can make a box plot to find out that a particular value is an outlier or not. When does a box plot shows a value to be an outlier? This is my question. When does a box plot tells you that this particular value is an outlier? Right. So suppose it says case number 2. Case number 2, whose value is 9, suppose whose value is 9 is an outlier. Is an outlier, is an outlier as per the box plot. As per the box plot. Right. Now why does the box plot say it's an outlier? That is what my question is. और अगर वो आउटलायर है तो नेचुरली आपको उस डेटा को ड्रॉप करना पड़ेगा. और जब आप डेटा को ड्रॉप करोगे आपका सैंपल साइज कम हो जाएगा. जब आपका सैंपल साइज कम हो जाएगा then you will have to again collect more samples and increase the sample size. This is the
Sir,
iteration you do in your
in
research.
that case, the outlier, the measurement, the variability of measurement may differ, or there is a significant difference between the other variables. That can be one of the case.
The outlier is for a particular variable. Every variable will have its own outlier. There is no comparison between two variables.
So the measurement, sir, what we have done, that may
The,
change. Measurement which we have used.
the measurement we have done is, suppose we have collected the scores out of 100, man.
Okay,
Right.
sir.
Now I've collected some data out of 100 and my box plot is saying that the case number 2, right? Case number 2 is of a student who has secured 9 marks, is an outlier, right? So my question is, why is the box plot showing that case number 2 whose value is 9 is an outlier? सिर्फ बॉक्स प्लॉट अगर कह रहा है ठीक है, आपको ये तो मालूम पड़ गया कि आपके डेटा में एक आउटलायर है, और उसने आपको ये भी बता दिया कि वो केस नंबर 2 है. आप उस केस को अपने डेटा में से डिलीट कर दोगे, राइट? बिकॉज आई डोंट वांट टू यूज एन आउटलायर फॉर एनालिसिस. आई डोंट वांट टू यूज एन आउटलायर फॉर, बहुत से लोग हैं उनको पता ही नहीं है कि हमारे डेटा में आउटलायर है और उस पूरे डेटा को वो मॉडल बनाने में यूज कर रहे हैं. हाउ डू यू थिंक यू विल मेक अ गुड मॉडल व्हेन यू हैव टेकन एन आउटलायर इनटू योर consideration? So, but why my question is to be theoretically sound, right? Why do you think that case number 2 whose value is 9 is an outlier? What is the reason for it? Now this is where, like normality, there is also a calculation to find out whether the value is an outlier or not, which the box plot is doing at the back end. Right? Graph is good, but then you should be theoretically sound also. Now, this is where you need two values, quartile 1 and quartile 3, Q1 and Q3. Now, Q1 is what? Can somebody try? What is quartile 1? What is quartile 1? Can somebody speak, sir? Quartile 1 क्या होता होगा? Because all these values are calculated in a second by R. It will give you that value, but then you need to interpret. So Q1 is 25% mathematically, right? And Q3 is 75%. Now I'll tell you the interpretation, right? And all of you, please keep this in mind. If you really want to do a good research, right, all these things are very important. Just using some fancy words will not solve the issue, right? So 25% means what? If suppose Q1 is equal to 30 from my data and Q3 is equal to 75 or Q3 is equal to 80. Now, what do I mean by Q1 is equal to 30?
Sir, is it related to median?
Median is Q2.
Okay.
Which in my case was 60. Right. Now, what do I mean by Q1 is equal to 30? What do I mean by Q1 is equal to 30?
The data set lies below 30. Is it right, sir?
Hello, sir.
35% of data falls is Q1.
Yeah, it lies less than 30 or till 30, the data set.
So, if your sample size is 100, how many data points are below 30?
29.
If the value of Q1 comes out to be 30, then what does it mean? If your value of Q1 comes out to be 30, what is your interpretation?
1/4 observations are below 30.
1/4 means 25%, and
Yeah.
your sample size is 100. That means 25 observations have a value less than 30. That is the interpretation, right? Now, If your Q3 is 80, what does it mean? If your Q3 is 80, what does it mean?
75 observations are
Very
below
good.
80.
Yes.
Perfect. 75 observations, very good. 75 observations have a value less than 80. This is what is the technical meaning, right? Now, once I know Q1 and Q3, I can also find out whether a value is an outlier or not, reflected in the box plot. Reflected in the box plot. I do not say that you don't look at the box plot, but then you should have a reasoning that my box plot gives, why does my box plot gives you the outline? So what is it you do? You calculate IQR, right? IQR stands for interquartile range. You calculate interquartile range. You calculate interquartile range, which is equal to Q3 minus Q1. Q3 minus Q1, right? And you can always calculate it because I know it is 80 and 30. So 80 minus 30. 80 minus 30. This is the IQR.
So will
Now,
you please repeat?
see, you got the value of Q1 and Q3 from R or any from the R tool. It will give you the value of Q1 and Q3. You don't need to calculate it, right? So I'll
Yes,
show
sir.
you these values of Q1 and Q3. How do you get it from R? Now, once you get this value of Q1 and Q3, you calculate the interquartile range, IQR, which is equal to Q3 minus Q1 or 80 minus 30, which is equal to, for an example, 50. Now, this will help me to find out whether you get an outlier or not. So the condition is, if any value in my data, if any value in my data, is less than Q1 minus 1.5 times IQR, 1.5 times IQR, then this will be an outlier. That is what the research methodology says. If any value in my data is less than Q1 minus 1.5 times IQR, then that is an outlier, reflected in the box plot, reflected in the box plot. And the other condition is, if any value is greater than Q3 plus 1.5 times IQR, 1.5 times IQR, then that value will also be an outlier. One towards the lower side or towards 0, and the other towards higher side towards 100, if the data is out of 100. So you can have an outlier towards the lower side and you can have a data towards the higher side. Knowing the outlier is very, very important, because if you take those cases which have an outlier, you will not be able to do a good prediction or a good forecasting in a time series model or in financial analytics And this could be one of the reasons why your sample is not normally distributed. So in order to make it normally distributed, I try to find out whether my variable has an outlier or not, and then I remove all those cases which are the reason for an outlier. That makes my data clean. That makes the quality of the data good for doing some kind of a prediction or forecast, which we'll be doing next. So all this stuff you do, and this is what is basically known as exploratory data analysis. Exploratory data analysis, which forms the first part of your chapter on analysis. So whenever you write a chapter of the analysis in your research paper, the first thing you do is to do the descriptive statistics, and then you follow it with exploratory data analysis, in which you explore your data and you report the normality and outliers in the variables collected from your question. collected from your question. Once you do the exploratory data analysis and clean your data, then only we can go ahead with some kind of a forecasting model or a predictive model in financial analytics. In financial. और ये कुछ आप इसी तरीके से समझिए कि why do you put some kind of cleaning in your homes or institutions? Why do you install an RO or any type of an equipment? Because the quality of the raw water is not good. And if you drink the raw water, you are prone to get some disease because that is the quality of the water in our country. Similarly, if you don't remove the outliers, you don't check for the normality, whatever model you make in financial analytics, that will not give you the correct prediction or a correct forecasted value. So अगर आपका foundation strong नहीं है, so naturally your results will also not be strong. And don't say at the end of the day, sir, I got these results from a tool like ours. Because the quality of the input was not taken care of. The quality of the input was not taken care of. So now after so much of discussion, कम से कम आप लोगों को इतना समझ में आया होगा कि this is the first thing you do as a part of exploratory data analysis once you have collected the data. And this is just the beginning, I tell you. This is just the beginning, right? The more we work on this, the more finer concepts I can tell you, which you need to look once you start making a good model as far as financial analytics is concerned. Because financial analytics is like it is the quality of the variables play a vital role, right? Otherwise, you will be too much deviated from the actual values. The predicted and the forecasted values will have a huge deviation. So and naturally, if you are interested to do a quality research, right? If you are really interested to do a quality research, you should do an exploratory data analysis, which should tell me the nature of the normality of the variables and how many variables have outliers and how did you account for the outliers? How did you account for that outliers? Anything anybody would like to ask before I move forward? Anything, any questions anybody would ask? Because all of you, I think, are involved in some kind of a research and you can relate whatever I'm trying to tell you with your research. Okay.
Yes, sir.
Yeah.
Sir, actually, whenever we start any kind of test, when we understand that which particular test it is, so there are certain assumptions. So,
Yeah.
like if we take multiple regression analysis or something, the assumption itself says that the data should be normally distributed.
Correct.
So, I will just throw light on the outliers now. Means I started with sharp test, but now what I'll do is I'll just check the outliers also.
You check for the outliers also, right? And
Yes, yes, sir.
And remove those cases which have outliers.
Yes, sir. Yes, sir. Box
And then the first you remove is the outliers, and then you check for the normality of the variable. Right?
Yes, sir.
Right. So this is the way you actually proceed, right? And you are very like later on we'll come to this linear regression, right? Which is used for trend forecast, right? Where I'll tell you, right, that which are the assumptions which you need to follow. Those assumptions are very, very important, and you will see all the assumptions involve the concept of normality. लेकिन normality किसकी होनी चाहिए? That is what I'll tell you, right? But it will involve the concept of normality. It will involve the concept of normality, right? Anything else? Anything else? It's all. See, this is the way you should ask questions. This will help you to do a quality research. And I assure all of you, please do a quality research. Right? The reason is, if you see the latest Times rankings, which gives you the university rankings throughout the world, none of the institutions in our country is in the top 300. I did my graduation and post-graduation from two of the premier institutes of the country, but they too also are not figuring in the top 300. The very reason is our institutes don't have that quality of research. So that is why my focus in all these webinars is to ensure that you do a quality research. you do a quality research. And how do you improve the quality of the research? When you start checking for the outliers, when you start checking for the normality of the variables, and as somebody said, normality is very very important as far as linear regression is concerned. लेकिन आपको किसकी normality check करनी चाहिए ये मैं आपको बताऊंगा. That is what I'll tell you. Right? So you find, suppose out of 100 samples you get 10 outliers. Is it good or bad? Is it good or bad? What is the amount of outliers that you can digest as a part of your research? Any idea? What is the percentage of outliers which doesn't have an impact on the analysis? How much do you think? How much do you think? How much do you think? कभी किसी ने इस पे सोचा है? अगर आपके पास में 100 का सैंपल साइज है तो कितने आउटलायर्स your model can digest and you don't need to worry about that. Right? That value is 5%. If you have 5 outliers out of 100, you can easily manage it. You don't need to worry too much about the outliers. But as soon as it is more than 5%, the outliers will have a negative impact on your analysis. It will have a negative impact on your analysis. So this is the way. Now, अब नेक्स्ट क्वेश्चन आपको नेचुरली पूछना चाहिए था जो आप लोगों ने नहीं पूछा. राइट? ऑन विच वेरिएबल्स, क्योंकि आपके डेटा में बहुत सारे वेरिएबल्स होंगे. राइट? सो नेचुरली दिस वाज अ वेरी लॉजिकल क्वेश्चन ऑल ऑफ यू मस्ट हैव आस्क्ड मी. राइट? ऑन विच वेरिएबल्स do I check normality, or is it for all the variables? मैं इतनी डिटेल में नहीं जाता. The reason is I really want you should have a good quality of research. Right? So which are those variables जिनकी आप normality
dependent variable?
No, let us not talk of the dependent or independent right now, because we haven't started with a predictive model. Right?
Okay.
Suppose you have the data for 10 variables. You have the data for 10 variables. Right? Now, आप किन वेरिएबल्स का डेटा, आप किन वेरिएबल्स की नॉर्मलिटी को चेक करोगे? आप किन वेरिएबल्स की नॉर्मलिटी को चेक करोगे? इसका मैंने अगर नॉर्मलिटी चेक करने को कह दिया, इसका मतलब ये नहीं है कि आप सारे वेरिएबल्स की नॉर्मलिटी चेक करना बैठ जाओ. You are wasting your time and you are not doing it statistically correct also. So whose normality should I worry or whose normality should I check? हम किन वेरिएबल्स की नॉर्मलिटी को चेक करें या किन वेरिएबल्स की नॉर्मलिटी के लिए we should be worried about. Okay, then let me answer this question also, and then I'll specifically come to something where we can say what are the assumptions for that analysis. Okay, now what are the different kinds of variables which are there? कितने kinds के variables होते हैं? Dependent and independent is related to an analysis. What are the basic or broad varieties of variables in our data? One is what is known as a qualitative variable. One is what is known as a qualitative variable. Right? And the second one is what is known as a quantitative variable. क्वालिटेटिव वेरिएबल का एग्जांपल क्या हो सकता है? जैसे मैंने डेटा कलेक्ट करा है, आई हैव अ वेरिएबल लाइक जेंडर, इट्स अ क्वालिटेटिव वेरिएबल, राइट? देन आई हैव अ वेरिएबल लाइक सपोज सोशियो इकोनॉमिक स्टेटस. I have a variable like what is the kind of program that student is doing, a UG program, PG program, or a research program. It's a qualitative variable, right? So qualitative variables are also known as what? What? They are also known as categorical variables. They are also known as categorical variables. You don't need to check the normality of categorical variables. Not required. Not required to check. Not required to check the normality of categorical variables. और categorical variables में भी दो टाइप के measurements होते हैं, right? There are two kinds of measurements for a qualitative variable or a categorical variable. One is known as nominal and the other one is known as ordinal and ordinal. Right? So nominal is like what? Gender. You don't need to check the normality of gender. Absolutely not required. Absolutely not required. Right? And you don't need to check the normality of a variable which is ordinal. Right? Ordinal कौन सा होता है? Ordinal का best example आप दे सकते हो? वो कौन सा
Order.
measurement? That is what is known as a Likert scale. I think आप लोगों ने Likert scale का नाम सबने सुना
Yes,
होगा,
sir. Yes.
right? You say strongly agree to strongly disagree. That is a Likert scale. That is a Likert scale, right? Strongly agree to strongly disagree. That is a Likert scale, right? इस डेटा की नॉर्मेलिटी चेक करने की जरूरत नहीं है, बिल्कुल भी नहीं है, right? You don't need to worry about the normality of a variable which is measured either on nominal or ordinal like Likert scale. Then you have a qualitative variable, right? This is the quantitative variable. आपको इन वेरिएबल्स की नॉर्मेलिटी को चेक करना, लाइक मार्क्स, हाइट, वेट, राइट? ये सारे डेटा वो हैं जिनके आपको नॉर्मेलिटी को चेक करना है. स्टॉक प्राइसेस, राइट? यील्ड ऑफ क्रॉप. So you need to check the normality of these variables. Now, how do you measure the quantitative variable? वो कौन से दो scales हैं जिनमें आप quantitative variable को measure करते हो? One is the interval scale, and the second one is the ratio or continuous scale. Ratio or continuous scale. So if your variable is quantitative but measured on an interval scale, then also you don't need to measure the normality. तब भी आपको normality measure करने की जरूरत बिल्कुल नहीं है, right? Example of an interval scale, like suppose you take the data, like I have an engineering background, so we normally collect the data for temperature. Now, temperature is a quantitative variable measured on an interval scale, right? And
because there is no any zero, absolute zero.
There is no absolute zero.
Absolute zero.
Right? Because even at 0 degrees centigrade, the mass exists. That is why there is no absolute zero. There is no absolute zero. ऐसा नहीं होता है कि टेम्परेचर 0 हो जाए तो आदमी मतलब there is no existence of the person. That never happens, right? So that is why it is an interval scale. That is why it is an interval scale, right? And for a variable measured on an interval scale, you don't need to again find the normality. So you need to be worried about the normality only when your variable is measured on a ratio or a continuous scale. And most of the variables on which we collect data are generally on ratio and continuous scale. Right? So whether you are trying to collect the data for sales, stock prices, right? NAV of mutual funds, right? The number of air passengers flowing, all this are measured on the ratio and the continuous scale. So, क्योंकि ज़्यादातर variables are measured on ratio and continuous scale, that is why you need to worry about the normality of that variable. You need to worry about the normality of that variable. So this is just these are some concepts which you need to understand, right? And these concepts you keep in mind, right? If you are really looking for a good research paper, international quality research paper, right? All these key things play a very important role, and this is what they are looking in your research paper. This is what they are looking in your research paper, right? Now let us move forward and try to see two more concepts as far as financial analytics is concerned. One is what we call it as a predictive model. And I'll tell you what is the difference between the two, right? One is what you call it as the predictive model. And the second one is what you call it as a forecasted or a time series model. Right. Now I'll take one example and I'll make you believe why there are two different approaches to the same problem. I'll make you believe why there are two different models which we need to worry about as far as the prediction is or a forecasting is concerned. Right. Now, let me take an example. Suppose I want to make a model to predict the stock price. Suppose I am looking for a model to predict the fluctuation of the stock price which happens, so that I could be a good manager who can assist people in purchasing or buying a stock price or selling a stock price. That is what these people do actually, right? So naturally, you should be able to make a model which could tell you how will the stock price fluctuate as far as the time is concerned. Now, there are two ways to approach this problem, right? One is what we call it as a predictive model in financial analytics. And the other one is what we call it as the forecasted or a time series model for the same problem, right? Now, there are two things also which we need to worry about. One is that the model should give a good predicted value. Then only my model is worth it. It should give a good predicted value. Right. So now there are two concepts involved here. Right. One is what we call it as a causal model. Like linear regression. Like linear regression. Now, this model says what? That my dependent variable is stock price. My dependent variable is stock price. And what are the reasons of this fluctuating stock price are my independent variables. Now, what could be the independent variables? Can you suggest for anybody of you? What could be the independent variables which I should worry?
Sir, inflation.
One could be inflation. How do you measure inflation? Suppose I want the data of the inflation for every day. What is the data you will collect? Or what is the data you will download? You need some way. So you try to figure out, right, what is that variable which measures inflation? Right? What could be the second variable? What could be the second variable?
Interest rates.
Profitability
of
the company, whichever company you are.
Yeah, for the profitability of the company, right? So we need to worry about the independent variables. And these are few of the independent variables which all of you mentioned. Now, what the linear regression does is it makes a linear model. It makes a linear model in predicting the dependent variable, which is the stock price, based on the independent variables, inflation, interest rates, profitability, and so on. Right. Now, this will give me the predicted stock price. The predicted stock price can be the closing price of every day, closing price of every month, whatever you want to do. That depends upon what is that you are looking for. The closing price for every 1 hour, whatever you are looking or whatever you are trying to do, right? But then you need to know the independent variables which you think are impacting the stock price, Now, the beauty of linear regression is, right, one, naturally, it will predict the stock price every day, every hour, depending upon the unit you want to predict, right? What is the second thing you will be interested in, sir? Suppose you are the person who is trying to tell a person whether to buy or whether to purchase, right? What is the other thing besides the predicted price, which naturally linear regression will tell you, right? What is the other question whose answer is very important, which will add quality to your research, or which will add quality to the suggestions which you can make to a customer? What is that other question which will add quality to your research work, which if you answer will add quality to your research work? The one being the foremost is the predicted stock price. Naturally, that linear regression will do for you. But then besides predicted price, it can answer even a few more questions which are also important. So I would like to know कि कौन सा वो second question है, which if linear regression answers, it will be something that will make the quality of research look good. Can somebody suggest? You have a dependent variable. I'm just trying to give you a clue. If your dependent variable is the stock price and your independent variables are like inflation, interest rates, and profitability, then what is that second question, which if answered using your model, it will throw a very good light on your research.
To check the normality of the variables.
Naturally, we'll do that. That all things we'll do once we make the model, right? वो तो एक procedure है, right?
All the assumptions are supposed to be checked of linear model.
Correct. That also we'll do. That also we'll take care of. But right now I'm trying to answer that वो कौन सा second question है जो अगर आपकी research answer करे तो it will be considered as a good research. Or in the other words, what is the second question which you should answer from this linear model?
Sir, it's how strong is the relationship between the dependent and independent variable?
And the independent variable. Can we put this thing into
how strong or is significant, or it is significant positive or negative inverse? What is the relationship?
Let me put it in something a more refined way, right? See, how many, suppose to begin with, you have 3 independent variables, right? अब जैसे आप, so I'm giving you a clue to this answer, right? Now, suppose you are going from your home to your institute, right? Naturally, you will calculate in your mind how much time it will take, right? So, जब आप mind में ये calculate करते हो, how much time will it take? Where does the thought process starts from? Where does the thought process starts from? What is that you consider first? What is that you consider first?
Distance, the transportation model you're using.
The distance you will not consider because the distance has to remain same every day.
Yeah. Transportation, mode of transport.
What comes to your mind the first? Which variable comes to your mind the first?
Traffic condition.
The traffic condition. So naturally, you need to find out which is the most significant independent variable having an impact on the stock price. For suppose you have found out from your experience that the traffic congestion needs to be looked, and you know the traffic congestion is mostly between 8 to 9 a.m. So that variable is the most important as far as the calculation of the time is concerned. So what linear model can tell you, out of the 3 independent variables you took, which variable has the most significant impact on the stock price? So if it is the profitability, then you should find out how the profitability changes. Now you know profitability will have the highest impact on the stock price, and if the profitability of the company any day goes down, it is sure that the stock price will also go down. The stock price will also go down. So what linear regression can answer also is, besides the prediction of the stock price, it can tell you that which is the most significant variable as far as the prediction of the stock price is concerned. So if that you can tell, right, then it will be very important. Suppose you are trying to predict or make a model to find out what number of Pepsi bottles will be sold in Indore in the next month. Now this is the calculation which everybody does. The reason being, the company needs to make the according logistics, right? Now the sales of the Pepsi can be on a basis of number of independent variables like the price of the bottle, the amount of advertisement the company does in Indore, right? What is the next month's temperature in Indore? All these variables needs to be looked. And then you can find out which is the most significant variable. If advertisement comes out to be the most significant variable, then the company will concentrate on more advertisement in the city of Indore. If there are many companies, I'll give you examples, who spent a lot of money on advertisement, but their sales never went up. So naturally, they had some flaws in their analysis, or the analysis was not done. It was assumed that advertisement plays a key role, but whether advertisement plays a key role or not, that depends upon the model. Maybe you took this model for a different city, and Indore can be a different city. So this is what a causal model like linear regression can tell you. But then, as somebody said, we'll have to see the assumptions that should be met, for the linear model. If and only if these assumptions are met, then only your model will be accurate. That is the problem. If and only if the assumptions are met, then only you will have a quality linear model. And out of these assumptions, like which we'll be discussing, aap dekhoge, normality plays a key role. Normality of the variables play a key role. So I'm coming again to that issue. Why is normality important? Why is that important to be discussed? Right. Now, हमको किसकी normality check करनी चाहिए? That I'll come later on. But then normality will be a very important concept if the assumptions have to be met. Right. And if and only if the assumptions are met, then only your model will be good. That is what I'm trying to say. ऐसे मॉडल से क्या फायदा? अगर आपका मॉडल प्रिडिक्ट कर रहा है कि next month 1 lakh bottles of Pepsi will be sold, and in actual reality only 50,000 were sold, then your model is not good. You need to relook at the model, and that is why all these research takes so much of time. And these companies spend so much of money in financial analytics. Because unless until they don't know, why do you think this prediction of, just for an example, आपको क्यों लगता है that prediction of the number of bottles is important for the company? Anybody? Why do you think this figure of the number of bottles is important? And why are they paying so much money for this kind of a model?
For production planning as well as supply chain and
yes,
the demand.
Decision making, sir.
For production planning, very good. For logistics, because they have to prepare the logistics so that the bottles reaches the stores. The bottle reaches the stores, and they will also get to know whether the demand is going up or whether the demand is going down, right? And companies spend so many huge amount of money on making these models. So one is what you call it as the predictive model or a causal model like linear regression. The second approach I'll say is a non-causal model. A non-causal model. Like forecasting or time series models, or time series models, or time series models. Now, this is a new area which has evolved with time. And these models are also becoming very, very prevalent. These models are becoming very, very prevalent and more prevalent for financial analytics. For financial analytics, right? Now, I'll ask you a few questions. Do think and reply, right? Now, these questions are very important, and if you thoda sa aap sochoge, so you will get a new dimension why these models are becoming so important. Now, for non-causal models, we don't collect data for independent variables or IVs. We don't. ये एक बिल्कुल अलग टाइप की अप्रोच है. हम IVs पे डेटा कलेक्ट नहीं करते, right? I'm not concerned which independent variable is causing the dependent variable. The data is collected only with time. Only with time. Only with time. अब मैं आपको इसका रीजन बताता हूँ, right? Suppose I tell you the reason, and then you will believe that why people switch from a causal model to a non-causal model like time series. I'll ask you a few questions. Once you give me the reply, then you will believe in these non-causal models. Sales of any commodity is highest when? In our country, when is the sales of the commodity highest? You talk of any commodity, when is it highest? When do you think it is highest?
Festive season.
Festive season. Right. More so, if you pin it down, right? More so.
Hello.
More so around.
When demand arises, sir.
When the demand arises. So when do you think is the maximum demand in our country? When do you think is the maximum demand in our country for any commodity? Any XYZ? Be it a mobile phone, be it a laptop, be it any fashion goods, anything. When is it? When do you think overall it is maximum?
During festival season.
Occasion based.
During festival season. More so around Diwali.
Okay.
More
Okay,
so
sir.
around
Okay.
Diwali. Right?
Sir.
Or
Sir.
more so around Diwali. Right? आपने एक मार्केटिंग का बहुत बड़ा रूल पढ़ा होगा, that this is known as what? 80-20 rule. 80-20 rule. इसका मतलब जानते हो आप? This is the rule which most of the companies believe in. Right? 80% of the sales happens in and around Diwali, and the remaining 20% happens in and around the complete year. Right? Now you look at the non-causal model. Now time is only important. Whatever be the independent variable, right? The sales will dip down after Diwali, be it any commodity, So what I'm indirectly trying to say that I'll only consider two variables. One is the dependent variable, and the independent variable, is time. So when this happens, then you move to a different thinking altogether, and that is where you start considering the non-causal models, which comes under one umbrella of forecasting and time series models. Linear regression में क्या होता है कि there is a upward line. Even after Diwali, linear regression will always say that the sales will keep on increasing. But actually what happens is the sales dips down after Diwali. This is what a linear regression model will work very good between Holi and Diwali. But after Diwali, the linear regression model will not work, and that is where the time series models will come into picture. Time series models will come into picture. Now I'll just support my thing with one more data, right? Let me show you this R interface, right? And I'll show you one data, right, which will help you to appreciate my issue. Now suppose this is the data for, I'll just show you one data. Now this is the data for the stock price from January 1949 to December 1960. Suppose, right? And let me make a plot of this stock price. So I'll write one command to make a plot. Don't worry about the command. First try to understand. This is the plot. This is the plot.
Hello, sir.
Yeah.
You will be teaching us now how to do this.
I'll teach you.
Yes, sir.
Okay. Now, if you see on the right side, there is a plot, right? Now, this plot is of a stock price which is recorded between January 1949 to December 1960. Right. Now, what can you see? If you see the stock price, then the stock price is continuously going up and down, up and down, up and down, right? This is the nature of the variation of the stock price. And generally, this is the way, if you plot any stock price, you will see a graph, something similar to this, right? Now, what is happening is, I have plotted the stock price only with time. This is the closing stock price every month. I can record it every day. I can record it every hour. That is not an issue. But I have recorded it as the closing price every month, right? Now, if you see on this graph on the right side, you see continuously ups and downs, right? This is what a linear regression model cannot handle. A linear regression model can only handle if this graph, instead of ups and downs, was either a straight line going up or a straight line going down. That is what a linear regression can handle. I'm just trying to come to the point. If this is the nature of the behavior of your data, then why do we prefer more of a non-causal model compared to a causal model like linear regression? और अगर आपके पास डेटा ऐसा है where the plot is more or less going up, like I'll show you one more plot. Let me make that graph of one more data, right? This is of a different stock price. Now, can you see this on my right side? Now, this is the data of a stock price, a second stock price. अब आप इस ग्राफ में देखोगे, this is more or less going in the upward direction, and there are no major ups and downs. The reason I have showed you two different graphs is this can be a causal model for predicting the stock price. And the first graph which I showed you, if I show you this graph, then naturally that is the graph where there were continuously ups and downs. There we require a non-causal model. So आपको उस stock price का fluctuation देखना पड़ेगा, right? It is true for stock price or anything. The concepts will never change. But I'm just trying to put into your mind, depending on the nature of the past pattern of the behavior of the stock price, I'll have to take an approach which could be a causal model like linear regression, like the one which I'm showing you right now on the screen. Right? This graph doesn't have continuously ups and downs. It is more or less going straight in the upward direction. Right? So I can go in for a causal model, check for normalities and all those concepts. If you have a graph like this, the one which I have plotted later on, right? I'll just plot it again for all of you. If this is the kind of graph you have, then this is continuously ups and downs. Then you need to go in for a time series model, right? And once you switch to a time series model, then you don't need to worry about too much about normality. Then there is something else which will come into focus. Something else which will come into focus. So मेरा aim basically आप लोगों को ये बताने का था कि looking the past pattern of the data which in financial analytics you are trying to make a prediction on. क्योंकि आप कोई ना कोई prediction जरूर करोगे, right? You will take a stand. Should I go in for a causal model or should I go in for a non-causal model? Right. Now, let me concentrate because most of the financial analytics data basically believes on a non-causal model. So I'll give you a brief description of what are the different non-causal models which we generally work on. What are the different non-causal models which we generally work on? But I'm not trying to say that you will omit causal models. Again, both perspectives are there. And that is why this financial analytics domain is sophisticated, complicated, right? Because we need to look at both the sides of the story. You need to look at both the sides of the story. Okay, so let me give you a small introduction also to this arc where I'm drawing all these graphs, Now, to do this analysis, there are a number of tools which are available in the market. Let me write it down for all of you. Right. Now, analysis using a variety of tools. Right. Now, these tools also come under two basic categories. One is known as licensed tools. Licensed, right? I'm not paying attention to the spelling right now. So licensed tools, and the other ones are known as the open source tools. आप लोगों ने कुछ licensed tools के नाम सुने होंगे? Can somebody speak?
SPSS.
SPSS.
Right. The most popular is the SPSS. Then you have like you have Atlas TI, right? You have in vivo.
Yes, Atlas.
You have MATLAB.
eView.
You have eViews. These are all licensed.
eViews.
Stata.
These are all Stata, right? These are all licensed applications. So naturally, you need to have a license to work on these applications. And then you have some open source tools. And the two most popular open source tools is R and Python. R and Python. Right. I also started my learning from, because I come from the engineering background. So I started with MATLAB, but now I have shifted to R and Python. Right. Now there's a naturally for the license tools, you have these ones, but you need to acquire a license to work on it. So when I was associated with my college, both IIT Kanpur and Delhi, I had access to MATLAB, and it's an expensive application. So I used to work on it. But then when I shifted from there, I never had access to these applications. So I used an open source tools like R and Python. Now these are, you can easily download from the net, and install it.
Sir, I perform R through Anaconda.
You can perform R through Anaconda also.
Okay.
Right? Or you can, the best is to download. Anaconda is better for Python.
Okay, okay.
Right, and for R, you use the CRAN website. I'll show you that. Right. So you can download these applications from the net and install it. That is the first thing. You don't need to have any license to use it. That is the first difference between a licensed tool and an open source. I'm not debating anything whether you use what. That is not my interest. My interest is just to pinpoint what is the difference between the two. Right, at least give you a clear picture of the difference between the two, since I have used both of them. So you download it from the net and install it. Right. Second difference is the license tools are a little easier to use because they are menu driven, like Windows. The R and Python are where you need to write some code. But what I can convince all of you is writing this code either in R or Python is very, very easy. The only thing is if you are taught in a systematic manner, everything is very easy. Right? That is what I can guarantee all of you. Right? Even if you don't have any programming background, any coding background, I've seen so many students, so many research scholars who never had any programming or coding background, and they are successfully using R and Python. That is one more difference. You will have to write some code as I was writing. The third thing is these open source tools. These open source tools have libraries or packages. Libraries oblique packages which are very versatile. And the research community is developing these libraries and packages every day. As of now, in the morning, there were 20,000. So before I started your session, I was just checking how many libraries and packages do we have till today's date. So there are 20,000 libraries and packages. There are 20,000 libraries and packages available. 20,000 libraries and packages available. So you think of anything, right? You think of any kind of a research doing, it is possible if you use an open source tool like R and Python. The licensed tool are they are good, but naturally they have their limitations. They have their limitations.
बच्चों का रिजल्ट आ गया देख
So
लो
that is the difference between
डैडी को बोला रिजल्ट आ गया नहीं मिला था देख लो
that is the difference between a licensed application and an open source tool. That is the difference between a licensed application and an open source tool. Now, where can you download R from? Right. So I'll tell you the site to download R, so that after my session, all of you can use it also. Now, how to download R? You go to the Chrome browser. Right? And the moment you see, this is my email. So you just write download R. You can see on my screen. You just say download R, and you go to the CRAN website. This is the best website. So download R for Windows. Download R for Windows. Right. Now you can download this R for Windows. Right. I'll just copy this website and put it in the chat box. All of you can use this. So this is the CRAN website. Right. This is the most authentic website to download R. So you can just download this R, right? And you'll get an executable file. Just double click on it, nothing much, right? Your R will be installed. The moment the R is installed, you'll get this kind of an icon on the desktop. I'll just show you on my desktop. This is the icon which you get on the desktop. The latest version is 4.0.3. Once you double click on this icon, this is the console which you will get. Now this is where you will start writing the code to do some kind of a statistical analysis. So the first thing is to download R, then to install R. The third step naturally is what? To import a data file into R. To import a data file into R. Right?
Sir.
Yeah.
Sir, I got 4.0.5. Is it new version or old one? 4.0.5.
It is correct. This is the latest one, 4.0.5.
Okay.
The latest one is 4.0.5, and always use the latest version, because the latest version has the latest libraries, so that you can use the best libraries available or the recent libraries available. Right? Every fortnightly, this R version gets updated with the new libraries. So always try to use the latest R. That will give you access to the most recent and the best libraries as of now available. So I also keep on updating, right? As my sessions keep on happening, I keep on updating my R so that I'm using the most recent libraries. तो अब आपका R इंस्टॉल हो गया और R आपने कंसोल को ओपन कर लिया. अब नेक्स्ट चैलेंज नेचुरली क्या है? नेक्स्ट चैलेंज है to import a data set into R, because that is where, unless until you have the data in R, how will you work on it? How will you work on it? So naturally you will import the data in R. You will import the data in R. Now, what should you look for when you are importing the data into R? Any idea? What should you look for when you are importing a data file into R?
Sir, proper extension should be there.
Proper extension should be there. You are very close to the correct answer, right? You should know the extension of the file which you are importing, which you are importing. अब जैसे आप देखिए मेरे पास एक ये फाइल है, मैं आपको डेटा शो करता हूँ. This is a file on which I have collected some data for the students, right? And my sample size is around 200. One is the ID or the roll number, gender of the student, race, socioeconomic status, school type, program, and then some scores in read, write, math, science, and social science. This is some data which I have collected. But naturally, before I do any analysis, I need to import this data into R. I need to import this data into R. So once you are importing the data into R, the first question you should answer is what she was saying was absolutely right. Right? You need to worry on what? What is the format? What is the format of the data? What is the format of the data to be imported? To be imported. Right. Now, what are the popular formats available on the net? Can somebody? What are the popular?
Excel.
One is the most popular format is what?
Excel.
It's not the Excel. Excel is proprietary.
CSV.
CSV, sir, CSV.
The CSV.
CSV.
मतलब क्या होता है? Comma separated value. Comma separated value. The second one you can say is the Excel. XLS. The third one is the data which you get from SPSS, which could be .sav, which could be .sav, right? Then suppose you get a data from Oracle, so .sql, right? You get a data from Microsoft Access, which is .mdb, right? What is common in all these formats? What is common in all these formats? From where can you download the data for the stock price?
Government websites.
Amphi.
Which website?
Amphi, sir.
Amphi.
Yes.
And even the better one is what?
NSC.
BSc.
BSc NSC. Yes, BSc NSC.
India.com. Right. आप इस वेबसाइट से नेट को डाउनलोड कर लोगे. जब ये डाटा डाउनलोड होगा इसका फॉर्मेट क्या होता है?
CSV होता है सर.
इसका CSV होता है. Right. So it is very easy to get the data of .csv format from the BSc site. Right. And this are the different, ये कुछ formats है जिन पे हमको डेटा मिलता है. इसके अलावा बहुत सारे formats हैं जिन पे नेट पे डेटा अवेलेबल है. So we need to look at the format in which the data which we have downloaded. What is common in all these formats? Somebody. What is that technical what is that technical answer which makes all these formats common? This is what is known as a structured data.
रियान से बोलो बेड के नीचे देखे,
This is what is
इसके
known
रूम में
as a
होगा.
Structured data. Structured data. इसको basically हम लोग कहते हैं structured data. Right? All this comes under one umbrella, which is a structured data. Structured data means what? Structured data means what? That the data has rows and columns. Rows and columns. Now there is one more. In financial analytics, you also get unstructured data. You also get unstructured data. Right. Now this is a new area which is emerging where the data is unstructured. And you cannot change the parent form of the data because that is the way you are getting the data. Right. So unstructured form, I'll give you some examples. .pdf, .doc, right? .json, right? ये बहुत सारा data है जो unstructured format है, which doesn't have rows and columns. Now R has the potential to even import the unstructured data. It has the potential to import the unstructured data, right? So you need to know what is the format of the data which you need to import. Now suppose my data, the one which I have showed you, is a CSV data, and let us see how to import a CSV file into R. So to import a CSV file into R, my file name is hsv2.csv. hsv2.csv. Now let us see कि हम इस डेटा को कैसे R में import करेंगे, and then we'll see how to work on this data. How to work on this data. So I need to type some command or some code in the R console. I need to type some code in the console. Let me type that code and then I'll explain what does it mean actually. Right. So this is my R console, जहाँ पर आपको ये greater than sign मिलेगा. Now whatever you need to do is in front of this greater than sign. Right. Two things you remember. One, whatever you type is case sensitive. Right. If it is small c, it has to be small c. If it is capital C, it is to be capital C. So that is what you should remember when you are typing the code in R. And that is the difference between a licensed and an unlicensed application. In licensed application like SPSS, MATLAB, whether you type in small letters or capital letters doesn't make the difference. But in any open source application like R and Python, you need to type the correct case. So what should be the command to import this file? The name of the file is hsv2.csv. So let me write that. First, I'll tell the name of the object in which this file has to be imported. Suppose the name of the object is data. So data, data, is less than and dash. Less than dash means equal to in R. Right. Now the function to be used to import is read.csv. 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 Simple. And then you start the brackets and type the path wherever you have the file. So inverted commas. So my file is in D drive. So d:/hsv2 dot hsv2 dot csv, inverted commas, close. Simple. Then there is one more argument to be written, comma, header is equal to true. Header is equal to true. Header is equal to true means if you see my file, the variable names are written on the first row. These are the variable names. So I am telling R that the variable names are written on the first row. The variable names are written on the first row. So I just write this and push an enter. Right. Now you get this greater sign again without any error message. That means I am able to import this file into R. I am being able to import this file into R. Now let me see whether I get the data or not. Only the first few lines. So I write head, H-E-A-D. Head means show the first 5 lines of the data. Head of data. Head of data. And enter. So you can see ID, gender, race, SES, school type, and it shows me the first 6 lines of the data. First 6 lines of the data. So now I'm pretty sure that I've been able to import the data into R. I've been able to import the data into R for any analysis. For any analysis. So what I'll do is, how many of you have this R in your laptops? How many of you have?
I have both Anaconda also and R CRAN also.
Okay.
Yes,
So
sir.
what we'll do is, I'll share this file with all of you. I'll share this file with all of you, right? And what you can do is you can open this file and see that whether you can import this file into R or not.
Yes, sir.
Right. So that
if
will
we
give
say
you I'll send this file to Neha ma'am, right? She will be sending it across to all of you, right? Ma'am, can I send you the file?
Yes, sir. Of course. Done.
Just you can share this file so that they have some hands-on practice also,
Sure,
right?
sir.
And that will make them a little more confident.
So if we save this file on desktop, the drive we gave like D, the command will
Correct.
change.
Yeah, the command will remain same. The only you need to give the address of the desktop, and I'll tell you where do you get the address of the desktop. You just place the file on the desktop and then share me your screen. I'll tell you what is the path to the desktop.
Okay,
The rest of the command will remain same. Right? If this is the way you ask your questions, your doubts will be cleared, right? And that is why I'll be sharing this. मैम आपका आईडी क्या था?
Sir, Neha Sahu @ipsacademy.org. IPS Academy.
IBS.
IPS.
Academy.org.
Done, sir. I'll be mailing in 2-3 minutes.
Just mail this file. All of you download this file and just write this command on your R editor and show me your screen. I'll tell you how to move about. This will give you a lot of confidence in working in R. At least make the beginning. Otherwise, it will be more of a one-way communication. All of you download this file and then you open your R editor and type this command, right? And then I'll guide you if there is any mistake in importing the file into R. Any problems you ask. And then we'll see how to check for normality and and draw in a box plot. So that will concept the theoretical concepts भी आपके clear हो जाएंगे थोड़े. But the most important is to import this file into R.
Participants, please check whether you received the files.
If you are not able to import it, just share your screen.
Yes, we have this.
Done.
And don't change the case of anything. This is case sensitive. So once you have got the file, you just download it and then write this code for importing the file. Just change the path wherever you have downloaded the file. My file was in D drive. That is the only care you need to take. Take your time, but try to do it. That will give you a lot of confidence. At least your beginning will be made. If you have any problems in importing it, do share your screen. As we'll move along, you will find the things very interesting. Because this is the way actually you work on the data. And it is possible to do everything in R.
Sir, data and then space we have to give or no space?
No space. No, there is no space anywhere.
Okay. And so data, then for
Then less than sign and then dash.
then dash read dot
Read dot
CSV,
CSV.
then bracket inverted commas. For desktop, what should I say?
You just share me your screen, I'll tell you.
Who wants to share the screen?
Ma'am Neha Shrivastava.
Neha ma'am. Ma'am, एक minute. I'm
Ma'am,
allowed?
I'll just open my camera. I can show like that.
Fine. I had open. You can share your.
I'm using laptop for
and mobile.
R and mobile. Yes, it's separate two devices.
Fine.
So I just
got it.
If somebody has imported the file, also you can show so that I can see that you have the data now in R.
Sir.
You just enlarge that so that it comes on the entire screen.
So is it?
Yeah. Okay, now you go to your desktop. You minimize this because I need to know the path. Where is the file? Just click on your file.
It's here, sir.
Right click on it. Right click on the file.
Right click, ma'am.
Don't open it. Right click on
you
the
had
file.
open it.
You right click on the file and select properties. The last option, properties.
Right, sir.
Yeah. Now can you see in the above the path of the file?
Yes, sir. It's C colon and user slash
you write the same thing in that editor.
Okay, got it. So can I copy paste that?
You can copy paste it.
Okay, got it, sir. Got it.
Anybody else who has been able to import the file? Anybody else who has been able to import the file?
Sir, almost participant had that well.
Once you have imported, you just check the first 6 rows using the head command. That will make sure that the file is successfully imported.
So it's giving error to me. Please check.
Just put it on a bigger screen.
Sure, sir.
Right. थोड़ा सा आप कैमरा और जूम करो मैम. Okay. You change the direction of the slash. Instead of backslash, you make it
desktop.
Oh, yes.
Front slash.
Rest everything is fine. Just change the direction of the slash throughout.
So I have to rewrite it. It will not take it like
You use this up arrow. On your laptop, use that up arrow.
Yes, yes, sir.
So that command will come again where you can change.
Yes, got it. Okay, sir.
Any other participant who wants to share a screen?
Again error, sir.
You just can you put it on the chat window? Acha, you are using that laptop. Okay. So you have changed the direction of the
Yes,
slash
sir.
throughout.
Yes, sir. B2 CSV.
Just read data is less than, or you just see on my screen. See, this is the command. Just match if there is any wrong.
Yes. Okay, sir.
It is comma, header is equal to true. Next, we'll check the normality and the outlier. Next, we'll check the normality and the outlier. But for that, it is necessary that you are able to import the file. Then only you will be able to follow.
Yes, the comma address will be.
All the slash should be front slash.
Sir, I'll retype it.
You can retype it. See, I've put that in the chat window also. But then you are using your laptop separately. So you can check in the chat window, the same syntax should be there.
Sir, in chat window, the command is not there.
Okay, I'll put the command.
Yes, sir. Received, sir.
Some people have written that they have done it.
Hello, sir.
Yeah.
Sir, from where can we find the syntax?
Syntax of?
Syntax of the same file.
No.
The link, the one that you've written like d:/hsbc.csv.
You right click on the file and select properties. You right click on the file wherever you have downloaded it and you select the option properties. From there you can copy paste the address wherever you have downloaded the file. Can anybody share the screen with the head command so that I know that some of you have been able to import the file into R?
So properties is only showing hsbc2.csv.
You
So
see
that
below that. You see below that. It will show you the location. That will also show you the location of the file.
yes, sir, got it.
Sir, I'm also getting error all the time. I tried.
Can you share your screen? Somebody
Yes,
who
sir.
is working on the laptop with the Zoom. See, you go to this edit and go to this graphical user reference and increase your font size, so that whatever you are typing in the laptop is also visible. Once you go to this GUI preference, you select the font size as 14. So that will increase the size of the font and the code will be easily visible.
Yes, sir, I did it. So now I am showing through my camera. Can you see this?
You just put it on this. Now, yeah.
So I tried by both the ways, like on my right side and left side, like this, but it is not coming. It's coming error all the time.
मैम इनका ये फुल स्क्रीन पे आ सकता है क्या जो ये शो कर रहे हैं?
Yes, sir.
Now it is fine. Correct. Okay, let me see your code. Read.csv colon. See, you change the direction of the slash ना
No,
आपने
no, sir.
slash-
I did it by both the ways. Like first I did like this on my right side. Then it was
देखो
again
आपने
giving me
स्लैश का
the
डायरेक्शन कहाँ चेंज करा? आपके सारे स्लैश अभी भी बैक स्लैश है ना?
so same.
आप एकदम एक फाइनली टाइप करो आप विदाउट प्रेसिंग एंटर.
Okay. So, 1 second. Sir.
See, he says, Ali Mufti says that he has done it. Sir, can you show your screen? Is it possible for you to show your screen? So that the other people can also see.
So till desktop, it is my location from where I copy and pasted.
हाँ तो
Now,
आप देखो जब टाइप कर रहे हो तो भी आपका स्लैश का डायरेक्शन गलत है ना? सी
sir,
कोलन वो स्लैश का डायरेक्शन तो आप चेंज करो.
I'm use front slash.
This is backslash man.
Yes.
फ्रंट स्लैश. सी कोलन के बाद में आप फ्रंट स्लैश यूज करो.
sir, as
वो तो प्रॉपर्टीज में तो डॉस चलता है ना. ये इस एडिटर में दूसरा डायरेक्शन चलेगा.
okay, sir. I'm not so good in this. Okay.
Hello. Sir, I have changed the direction of slash. Still, it's showing an error.
Okay, can you show your screen?
Sir, actually, I'm using mobile phone and laptop.
So now you see this, the one she is doing it. इसमें आप देखना ऐसे ही आपका भी होना चाहिए.
Now, sir, I'll put
Now again put a slash.
Slash or colon or slash.
Yeah. Now hsb2.csv. The same slash. Correct. Once you write CSV, inverted commas close.
Inverted comma close,
Yeah,
comma.
Header is equal to true. HEADER is equal to capital true.
Comma, bracket close.
And then bracket close and enter.
Got it, sir.
Yeah. Now you type
I got
head.
no problem. Yes, sir, I got it.
You type head. HEAD.
Small.
Small. Everything small. And bracket में data. And then bracket close and enter.
Yes, sir.
Hey, what have you written? Head. HEAD आप type करो.
Sir, is HEAD.
And in the brackets you type data.
Data. HEAD data.
ये तो ठीक है. तो आपका आया क्यों नहीं है? read dot
function.
आप खाली डेटा लिख के एंटर करो. अभी भी आपका डेटा नहीं आया. यही तो चेक करना है. आपका डेटा आना चाहिए इसमें.
नहीं आ रहा सर, कुछ बहुत सारा कुछ आया, वो डेटा नहीं है.
आप ऐसा करो, फाइल को जो है, क्योंकि आपकी फाइल इंपोर्ट तो हो गई है, आप इस फाइल को यहाँ से कॉपी पेस्ट करो. आपके में सिस्टम में डी ड्राइव है क्या?
हाँ सर.
आप
नहीं.
कॉपी करो इसको डी ड्राइव में, डी के रूट में कॉपी करो, जस्ट टू मेक लाइफ सिंपल.
Okay, got it sir.
And then you write the command for the D drive.
Same command
Same.
as you did.
Yes. Then you write the same command which I have written. Okay. Next, we'll move on to check the normality for a variable in R. To check the normality of variable read. Just
So
for
your
example.
screen is not visible, huh?
Okay. To check the normality of variable read in R. Now we'll do it two ways. One is graphical and one is the statistical test. The statistical test is Shapiro's test, Shapiro-Wilks test. Now all of you see the code and then I'll tell you the interpretation. Shapiro's Wilks test. So you'll go to the R screen and then type Shapiro.test, Shapiro, Shapiro.test, bracket start, and then data dollar, and the name of the variable is read, data dollar read. Now once you do this and enter, this is the p value which you get, 0.000553. आप लोग करके देखो, are you getting this p value or not? And then I'll tell the interpretation.
Got it, sir.
Very good. So the p value, this is the beauty of R, it will give you the ready-made p value. And the interpretation is, अगर ये value 0.05 से कम होती है, then your variable is not normally distributed. Then your variable is not normally distributed. So that is the first thing which you get to know about the variable. So I'll just write it down. All of you can make a note of it. If p value from R, if p value from R is less than 0.05, is less than 0.05, then the variable is, this is what will create problems. Then the variable is not normally distributed. So that is the first bottleneck which we generally face in the data, something logical. So if the p-value from R is less than 0.05, then the variable is not normally distributed. Now the second way is to make a QQ plot to support this test. QQ plot to support the statistical test. So in your research paper, you should do both to support the statistical test. So to do this, we'll write 2 lines of code and this will, R will give me a graph which I'll interpret. So one is you write QQ norm, and under bracket, data dollar read, data dollar read, data dollar read. So this is the graph you get. And then I need to put a line. So for the line you put QQ line, and then under bracket, data dollar read, data dollar read. Then put enter. Now this is the line which you get. You can copy paste this graph from here to your research paper. You just say copy and you say copy as a bitmap. Copy as a bitmap, and then you can paste it in your Word file. Now, the interpretation is that if you get points which are away from this diagonal line, then that means your variable is not normally distributed. And that is what your statistical test is also saying. So I'll just write it down. Or you can copy it like this way, copy as bitmap, and then you go to your Word document. This is your Word document. You paste your cursor, and then you say paste. See, this graph comes over here. Right? And then you can say, you can write your interpretation that if the points are away from the diagonal line, then the variable is not normally distributed. Then the variable is not normally distributed as supported by the test. As supported by statistical test. So that completes one part of the story, as supported by statistical test.
Hello.
So the first thing is you do the Shapiro's-Wilks test, get the p-value, and then you support that p-value with the quantile plot or QQ plot. And you can copy paste the QQ plot from the R editor to your research paper. Now this is what will add quality to your research. You have been able to tell about the normality of the variable. So since your variable is coming out to be not normal, we can go in for a non-causal model. So all of you do that. आप लोग करके देख लो.
Sir, when I'm clicking on the image, it's showing only the option of copy image, and when I've copied it and pasted it, it's not showing. It's not pasting.
No, you don't get this option as you just put your cursor in the center of the image.
Yes, sir, I've done that.
You will get an option as copy as bitmap.
No, sir, there is no such option. Copy image address and copy image are the two options.
Can you share your screen or it's on your laptop?
It's in my laptop, sir.
So just put on your camera and if I can see it, I'll tell you. The other people can also try. आप देख लो अगर. Are you getting this quantile plot or not?
Yes, sir.
Okay.
Got it. That.
Right. Next, we'll go to check for the outlier using the box plot. So next is to check. I'll just share my screen. To check for outlier, using box plot. Now let us write the code to make the box plot for the variable read. Simple one. You just write box plot and bracket start and then data $read. And then now if you can see on the right side, this is the box plot. And there are no circles either below the lower horizontal line or above the horizontal line. So that is one good indication for all of us that my variable doesn't have any outlier. Examination of the outlier is very, very important because our analysis is sensitive to outliers. So the command is box plot and under brackets data $read. And if you don't get any circles below this horizontal line, and this above horizontal line, then that means that there are no outliers in my variable read. There are no outliers in my variable read, and this is one of the good things as far as my data is concerned. Because in financial analytics, outlier is very, our analysis is very sensitive to the presence of outliers. And your research quality will also be good because people will appreciate that you have checked for the outliers.
Saurabh sir, but with the same data,
yeah,
I'm getting the values even out of that box.
No, are you getting circles, man?
Yes.
No, are you getting circles in the box plot?
Not in the box plot, but out of the box plot.
अच्छा, आप स्क्रीन शेयर कर सकते हो?
हाँ, yes
हाँ,
sir.
आप दिखाओ, स्क्रीन शो करो. Okay, where is
these circles?
No, these circles is of that QQ plot, ma'am.
Line and QQ plot.
हाँ, ये आप इस बॉक्स को क्लोज कर दो एक बार. हाँ, अब आप फिर से लिखो बॉक्स प्लॉट का कमांड. Very good. So this is the box plot. Now you don't get
that was overlapping.
That was overlapping.
Overlapping.
That was actually overlapping. This is one of the good findings. Right? Even the normality can be taken care of, but the outliers cannot be taken care of. That is one good thing which we have got from the data, that my data doesn't have any outliers. Now all of you check for the variable right. Just for an
Sir,
example.
Yogita ma'am want to ask something, right? Yogita ma'am?
आप पूछो मैम.
Fine, sir, you continue.
Okay. Now all of you can just, yeah.
सर एक बार और आउटलायर का कुछ क्राइटेरिया हमें चेक करना है, वो एक्सप्लेन कर देंगे प्लीज.
वो क्राइटेरिया है, देखो आपको वो क्राइटेरिया इज टेकन केयर फर्स्ट इन दिस बॉक्स प्लॉट, राइट. बॉक्स प्लॉट में आपको क्राइटेरिया खुद पर्सनली चेक करने की जरूरत नहीं है. वो क्राइटेरिया चेक होकर के ही बॉक्स प्लॉट आता है.
मतलब आप जो कह रहे थे कि जो अपने को जो आउटर साइड की जो लाइंस हैं वो हमारी अगर बॉर्डर से टच हो जाती हैं तो मतलब आउटलायर एग्जिस्ट करते हैं, और अगर गैप है तो
अगर आउटलायर होगा तो ये जो नीचे वाली हॉरिजॉन्टल लाइन है ना, इसके नीचे आपको कुछ सर्कल्स दिखाई देंगे.
ओके ओके, गॉट इट.
और जो ऊपर वाली हॉरिजॉन्टल लाइन है उसके ऊपर कुछ सर्कल्स दिखाई देंगे.
राइट.
और अगर वो सर्कल्स नहीं दिख रहे हैं, जैसे मेरे केस में, जैसे हम लोग के डेटा में है, दैट मींस देयर इज नो आउटलायर.
No outlier. Got it,
There is
sir.
no
Okay,
outlier as far as the variable read is concerned.
Okay.
और जो मैंने आपको दो बताए थे, क्राइटेरिया बताए थे, those criteria are taken care of once this box plot is made in R.
Okay.
So you
Yes,
don't
sir.
need to manually check for those criteria. But if
Okay,
somebody asks you what are those criteria, then I have told you that to get those criteria, that the you calculate the value of the interquartile range.
Yes, sir. Interquartile range. Q3 manually.
But manually you don't need to do it because that is taken care of in the box plot.
Right, sir.
Now all of you, just for an example, find if there is any outlier for the next variable right.
Saurabh sir?
Yeah. If there is any, you can just draw a box plot for the variable right and tell me if there is any circles you get below or above the horizontal line.
No, sir, I don't get it anything.
That
It's
means
perfectly
right
fine.
variable also doesn't have any.
Yes. Only the box plot middle line is shifted upwards.
This middle line is actually median.
Median.
The bigger, thicker line is the median.
Okay, sir.
The bigger, thicker line is the median. Right. Now, to get the descriptive statistics, you can write the command summary and then data $read.
Data $.
Yes. Now this will give you everything. The minimum value in the data, the mean value, the maximum value, and the 3 quartiles. First quartile Q1 is 44, Q2 or the median is 50, which I was saying, and the third quartile is the Q3. Now you can manually check also those 2 criteria which I told you for the presence of the outlier. That's the same criteria which the box plot is following in R to get those circles. So whenever you want the descriptive statistics, you can use the command summary, and then you can refer to the variable. Suppose I want the summary for the variable right, then I can write summary and then data $read ki jagah data $write.
So please, if you can repeat.
To get the descriptive statistics for a variable, the command in R is summary. So first I did it for the variable read, and then I have found the descriptive statistics for the variable write. And the descriptive statistics include minimum, maximum, mean, median, first quartile, and the third quartile. This is what I was mentioning in my discussion also.
So does this mean that you can move only one variable at a time? The table has more than 5-6 variables. Can I select all of them in a bunch and as a lot and do it? Is it possible? Or you need to move only one variable at a time? Data read, data write, data raise.
Right now, ma'am, you can do. I think. See, right now you will have to do one variable at a time to do for all the variables now. There is one more step in which we need to install an external library.
Okay, fine. Okay.
Right, so as of now,
this is a simple process. Of course, what you have thought is understandable and
all
doable.
you can do is summary data.
Okay.
See, this will give you for all of them.
Okay, sir. This is okay. Doable. Okay. Summary data.
Summary
Thank
data.
you. Thank you, sir.
But now the next thing is key. If you see in your data set, the next we do is now to take care of the categorical and the numerical variable. So for the numerical variables, everything is right. But we have a categorical variable like gender. Now the next thing or the next challenge in R is to convert this variable gender into categorical. So what we do is we first see that to check the structure of the file. So for that we write str and then data. Now once you do the structure, this will tell you that all the variables are integers, int. Int means they are numerical or continuous variables. But then gender is not continuous variable. Gender is a categorical variable where 0 is male and 1 is female. That is the way data has been punched in. So before we do the financial analytics, I need to convert this gender into categorical variable. So that is the next challenge which we have, right? For the continuous variables, everything is fine. We have checked for the normality. We have checked for the outlier. The next thing which we need to do is to take care of the categorical variables. So to take care of the categorical variables. Because once we do linear regression, one of the variables can be categorical also. So to take care of the categorical variables. So that means what? That the variable gender, which is still numerical, has to be converted into categorical. Then only we can make a causal model. So how do we convert it into a categorical variable? And then if you re-see the structure, then instead of int, it should come as a factor. So a categorical variable in R is known as factor. A categorical variable in R, a categorical variable in R is shown as a factor in the str command. In str command. So if you can see right now, this is coming as integer. So R will understand it to be a numerical variable, but actually it's a categorical variable. It is actually a categorical variable. So the next command will be to convert this numerical variable into a categorical variable. So the command I'll write is data dollar gender is assigned, and then I'll use the function factor, 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 and then the original variable is again data dollar gender. Then I need to tell which are the two levels. So comma levels is equal to C. C means concatenation vector 0, 1, because the original data is 0, 1. And then comma, then I need to tell what is 0 and what is 1. So labels is equal to C. 0 is for male. So inverted commas में male, comma, inverted commas में female. Bracket close and bracket close. This is the command.
Sir, female में inverted comma close करेंगे.
Data dollar gender.
Sir,
female में भी inverted comma close करेंगे. Very good.
Sir male का M.
Inverted close.
Male का M भी आप कैपिटल कर दो. लेबल्स में LABELS होगा. Now if you see the structure of data, see this will come as a factor with two levels. Now it is a categorical variable. This is the most crucial step as far as aligning your data with the analytics is concerned, where you have taken care of the normality, outlier, and now you are converting the required variable into categorical. So this is the command. I'll just highlight it for all those people. I'll put it in the chat box also. So one more exercise you can do now is for the variable prog. There's a variable prog which tells the program of the student. So the coding is 1 is for UG program, 2 is for a PG program, and 3 is for a PhD program. For gender, we had two categories, 1 and 2, 0 and 1, male and female. Now you can do it for the prog variable. And there are three programs, 1, 2, 3. One is a UG program, 2 is a PG program, and 3 is a PhD program. And then you see the structure of the file. The prog should also come as factor with 3 levels. Factor with 3 levels. So for an exercise, next what you can do is to convert this variable prog also into categorical. And the way we got gender as factor with 2 levels, you should get prog as factor with 3 levels. Any problems you have, you can show your screen. Just try it for the prog variable. Only the levels will be, instead of 0, 1, it will be 1, 2, 3. Any problems you have, just share your screen. And I'll just put in the chat box. There is a good book all of you can follow, Discovering Statistics Using R. And the name of the writer, it's a wonderful book. The name of the author is Andy Field. It's a very good book. This is what I follow. Right. It should be Discovering Statistics Using R. Anybody having any doubt? तो आप पूछ लो.
सर जैसे हमने यूजी पीजी और पीएचडी 3 लिया है,
हाँ.
तो हम लेवल में
लेवल में इन्वर्टेड कॉमास में तीनों अलग अलग लिखेंगे.
राइट सर, जैसे हमने मेल फीमेल किया वैसे हम इन्वर्टेड कॉमा करके
यूजी पीजी एंड पीएचडी.
पीएचडी। और सर जो लेवल होगा उसमें तो हमारे हमने जो अगर हमने मार्किंग करी है तो 1 to 3 के हिसाब से करेंगे ना, 0 1 and 3 2 भी लेंगे.
आपका डेटा 1 2 3 है ना. इस बार अगर आप डेटा देखोगे प्रोग्राम का तो 1 2 3 है. तो
हाँ,
लेवल
तो 1 2 3 ले लेंगे.
हाँ.
ओके सर, गॉट इट.
अगर डेटा 0 1 2 होता तो 0 1 2 ले लेते.
राइट सर.
Sir, what does this data dollar gender shows?
Data dollar gender shows that you are accessing the gender variable from the file data. जो आपने इंपोर्ट करा है वो डेटा में इंपोर्ट करा है.
ओके.
और जो आपने इंपोर्ट करा है उसमें से जेंडर वाला वेरिएबल है जिसको आप यूज कर रहे हो. अब जब नेक्स्ट प्रोग्राम का करना है तो आप डेटा डॉलर प्रॉग जेंडर की जगह लिखोगे डेटा डॉलर प्रॉग.
ओके सर.
That actually tells us which variable you are accessing from the data frame.
Okay, sir.
All of you are done with it? Finally, when you see the structure of the file, now you should get two variables, one gender factor with 2 levels and prog as factor with 3 levels.
Sir, I got error.
Did you get it for gender?
No. Sir, this prog.
Just show me your screen.
Just
prog का p आपने कैसे लिखा है?
यस सर, वो सेम फॉलो करनी नहीं, स्मॉल ही है सर, डेटा में भी स्मॉल है सर.
थोड़ा थोड़ा धीरे धीरे. हाँ, इस फैक्टर डेटा डॉलर प्रॉग कॉमा थोड़ा सा लेफ्ट में ले जाओ तो स्क्रीन दिखती है आपकी. थोड़ा स्लोली.
मैम स्क्रीन क्लियरली विजिबल नहीं है, थोड़ा सा मतलब बहुत ब्लर आ रहा है इमेज आपका,
इसीलिए मैं पढ़ नहीं पा रहा हूँ.
हाँ, वो इमेज बहुत ब्लर है उसका. हाँ, अभी बेहतर था. नहीं मैम, एक बार टैप करिए आपकी स्क्रीन पे. यस, यू हैव टू होल्ड एंड टैप जस्ट फॉर वंस. नो, नॉट रीडेबल. क्लियर नहीं है, इमेज क्लियर नहीं है. हाँ
सर, मैं रीड करके सुनाऊं?
That would be better option, sir.
हाँ
सर, डेटा डॉलर प्रॉग.
हाँ. आप थोड़ा थोड़ा दिख रहा है. आप स्क्रीन को मूव ना करो बिल्कुल तो दिख जाता है.
हाँ.
आप इनलार्ज करो थोड़ा.
सर, ये इनलार्ज करना उनके लिए चैलेंज होगा ना. हाँ, वहां से कर सकते हैं.
नहीं, वो पूरे स्क्रीन पे तो आना चाहिए ना मेरे ख्याल, जैसे इनका पूरा
मैम आप
screen-
एक और काम कर सकते हैं, आप मुझे व्हाट्सएप कर सकते हैं क्या? आई विल शेयर
हाँ,
इन
okay,
चैट
ma'am.
बॉक्स। आप
Sure,
कॉपी करके
ma'am.
मुझे व्हाट्सएप कर दीजिए, तो कैसे करेंगे,
Okay,
आप कर
ma'am.
पाएंगे?
हाँ मैम, मैं कर देती हूँ.
हाँ,
Okay,
आप
ma'am.
मुझे व्हाट्सएप कर दीजिए, मैं शेयर कर देती हूँ यहाँ पे।
Sure, ma'am.
श्योर सर।
बाकी लोग भी इसको करके देख लीजिए, दैट विल हेल्प यू अ लॉट, एटलीस्ट one part of the story will be over.
Right.
We are able to deal with the data.
Ideal.
किसी और को कोई प्रॉब्लम हो तो पूछ लो। So before we wind up, anything else you want to ask all of you, because this is a topic which can be continued for hours.
Right.
Because of time constraint ना. So anything.
सौरभ सर, आपको व्हाट्सएप किया है, एक बार आप देखना चाहेंगे क्या? स्क्रीन उनका क्लियर है, और आप बोले तो मैं यहाँ शेयर कर दूं?
नहीं, मैं देखता हूँ
जी।
ये पीजी के बाद में इन्वर्टेड कॉमास क्लोज नहीं है।
Yes, sir. Yes, sir. Yes, sir.
That is the only mistake.
Thank you, sir.
Right.
Thank you, sir. I got it.
Okay. So this is just the beginning of the financial analytics, right? And we were preparing the data for the analytics with some input into normality and outlier. But once we have checked for normality and outlier, then we'll discuss a little more concepts like normality of the errors, right? Stationarity of the series, right? Whether the series is stationary or not, right? And then the correlation between the errors, which is what is the Durbin-Watson test. So all these tests will now follow, right? And then we'll prepare the model, which model to use for causal and which model to use for the non-causal model. So this is the flow generally which we do, but then this is the first 3 hours for this, the way you start building the model. And the way you move forward, we have a number of tests and a number of models as far as financial analytics is concerned. But it's a beautiful area to work on, and you can use two best tools available in the market right now, either R or Python. Both have extensive libraries to do financial analytics. And whatever my input is that try to do a good research, right? What I can do is best is I can share my email ID. If any problems you have, you can write your problem.
Hello, sir.
Yeah.
Sorry to bother you in between, but can you please just once again repeat the interpretation of it? I've written the syntax and it is showing a table 1 to 12 of 200 entries, 11 total columns, but I don't know again how to interpret this.
The interpretation of what?
Of that data dollar gender wala syntax.
जो डेटा हाँ मैं कर देता हूँ, जो डेटा डॉलर सिंटेक्स वाला कमांड है, that command is to convert. See, initially this gender was integer. If you see this one, right? Integer means it's a numerical variable, but actually my gender is a categorical variable with 2 categories, 0 for male and 1 for female. So what I have done through this factor command is to convert a continuous variable into a categorical variable. मैंने शुरुआत में आपको बताया था वेरिएबल दो टाइप के होते हैं, either categorical or continuous. So once you import the file from CSV, the variable is imported as continuous. But before I do financial analytics, I want to tell the model that this variable is categorical. So to do that, you use this data $gender command. And once we have used this command, again, if you see str, then in front of gender, you should get factor with two levels. Factor with two levels in R means that it is a categorical variable with two levels, male and female. So similarly, I wanted you to convert the program variable into three categories: UG, PG, and PhD. UG, PG, and PhD. क्योंकि डेटा अपने आप कैटेगोरिकल में कन्वर्ट नहीं होगा जब फाइल इंपोर्ट होगी. The data will come as continuous, and this is our duty to convert the relevant variables which we think as categorical into categorical using the factor function in R. Using the factor function in R.
Right, sir. Now I got it. Thank you very much.
So this is the way you start actually with the normality, outlier, importing the file into R, right? And then the follow-up will be now, if we have more time, then the next step will be naturally to look for the normality of the errors, to look for the something which is known as the stationarity of the series, to look for the correlation between the errors, which is what is known as a Durbin-Watson.
This kind of race is actually.
Once you get all this, then you will be ready with a model. And we have the number of models you must have heard of, like simple exponential smoothing, Holt's model, ARIMA model, Garsh model, right? But to use those models, all these steps need to be done before you look for the model and to get the best predicted value for the stock price or the NAV or anything else. So this is from my side. Any further questions? Anything you want? I'll answer.
Participants want to ask anything else? Sir had already shared his mail ID in the chat box.
Just to, in case you have any issue as far as when you are doing your research and you want, but my whole attempt is you do a good research. That is the whole objective behind this session. My idea is to tell you that don't try to copy what others are doing, because this is what is not now. If you really try to publish your research paper in a good international journal. Don't look for Indian journals, don't read Indian books, all useless. Right, nothing against all this, but it's you make your fundamentals solid. That is what I want.
So I hope that participants had actually learned a lot, many things, the basics which are important, and the way you explained it, including the difference between the basic predictive forecasting and within examples. So that was wonderful, sir. And we hope that the participants are going to use the same in their analytics journey. So with the same note, I would like to extend the vote of thanks. Saurabh sir, thank you for being with us in this part, in the phase 3 of financial analytics, sir. So Saurabh sir, thank you.
Thank you all. Thank you for patiently hearing me for 3 hours. That itself is a wonderful job. And keep learning and try to do a good research. Thank you.
Sure, sir. We will. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you, ma'am.
Thank you. And again, there is another information for the participants. We'll be starting our third session by 2:30 sharp. The files provided by the resource person are already shared. Please make sure to download those files so that you can have hands-on practice along with him. Right? So that's all from our side. Thank you all. Thank you, participants. Thank you, sir, once again. And see you all by 2:30. We'll be starting the meeting at 2:15. Please make sure to join before 2:30 because the resource person will start sharp at 2:30. Right? Thank you all. Thanks a lot. Have a nice day.
Thank
you.